Let us start with section 1.1. First of all, we'll go and cover link aggregation. Inside link aggregation, we have to understand about a virtual port channel and port channel. So let's start one by one with these topics. Hi there, thanks for your enrollment. We are in 1 minute ad break. In this break, I'm going to show you that I have so many courses uploaded over Udemy. And if you're going to enroll my courses, you will get 95% discount every month, 3 times. First week, mid of the month, and the last week of the month. I am sharing the coupons. If you go and use those coupons, then my courses related to CCNP, related to CCI, all those courses, you are going to get heavy discount up to 95%. You can see the prices are a little bit higher here, but if you go and apply the coupon, the prices will go rock bottom. So go use those coupons. Suppose if you don't have those coupons, then you can always ping me over YouTube. You can send me email. You can ask for those coupons. I will provide you that coupon. So get the coupon, get the discount. Some of my courses over Udemy, they are bestseller. Some of the courses are quite new, like SD-WAN automation, DNA automation, CCI data center 3.0. Those are the new uploads as well. So please go continue your learning, take the coupon, enroll my courses, and study well. All the best. Hi there, thanks for your enrollment. We are in 1 minute ad break. In this break, I'm going to show you that I have so many courses uploaded over Udemy. And if you're going to enroll my courses, you will get 95% discount every month, 3 times. First week, mid of the month, and the last week of the month. I am sharing the coupons. If you go and use those coupons, then my courses related to CCNP, related to CCI, all those courses, you are going to get heavy discount up to 95%. You can see the prices are a little bit higher here, but if you go and apply the coupon, the prices will go rock bottom. So go use those coupons. Suppose if you don't have those coupons, then you can always ping me over YouTube. You can send me email. You can ask for those coupons. I will provide you that coupon. So get the coupon, get the discount. Some of my courses over Udemy, they are bestseller. Some of the courses are quite new, like SD-WAN automation, DNA automation, CCI data center 3.0. Those are the new uploads as well. So please go continue your learning, take the coupon, enroll my courses, and study well. All the best. What I have done that after this particular session, you'll find four small sessions. So four small 5 minute videos are there that I have recorded in a data center in the lab environment. Small videos, and even you will heard some fan noise as well in the back. Small video just to understand that how you can go and configure the VPC, and in that videos you'll find the small lab topology as well. Great. So we are going to learn, understand the VPC terminologies. What are the steps we have to do the configuration to the VPC in this section? Now, why we need VPC? We know that if we have three switches, and if you go and connect three switches, automatically a spanning tree protocol will come into the picture, and it will try blocking. The number is 50% of ports will be blocked. So you don't want uh, to block the ports unnecessarily, because in that case you are not using 100% of bandwidth, because 50% of ports will get blocked. Correct. So to overcome from that particular issue, we can use VPC as a virtual port channel method. And what is happening that when you are using VPC, so in this diagram you'll understand what is happening, that we are clubbing two devices and they will work as a one device. So instead having triangle, or instead having multiple link in a network, what you will find that suppose if you have this type of hierarchy where you have your core switch, they will find some straight line to the access switch, and from access switch you have the straight line to the servers. Correct. So in this manner, what is happening that you are utilizing 100% of the bandwidth because you are not forming triangles in a network. What you are doing, you have the straight line. So if a straight line is there, there is no loop, and that's the use case utility we have with the VPC. VPC is a nice way to provide the data center devices to do use of full bandwidth, all the interfaces inside the data center. Correct. So it will eliminate the STP block port. It can create L2 port channels like LACP, etc. And different type of platforms are there which will go and support VPC. Now in this diagram also you can see that we have block port due to VPC, due to STP. Sorry, and then when you are using VPC, that means you are overcoming that problem, and now you have the straight lines. Correct. So since you have these straight lines, so this diagram will look like very simple. This diagram is something like this. So you have a straight lines going from one place to other place. Great. So let's focus, understand more about the VPC technology terminology. Again, here also the same thing, you'll find that while you're doing the migration, whatever block port you have, and this is in the larger, in the broader perspective, and if we have n number of servers, n number of links, so obviously you can increase the efficiency of those at least 50%, because now you are using all the bandwidth, all the links, and even the migration of this non-VPC to VPC, that is also easy to do. Great. So now we understand that why we need VPC, because we want to do full utilization of bandwidth. Now when we are using new technology, they are coming with new terminologies. Correct. So what are the new terminologies we have? Even I have one small animation slide as well after this, so you'll understand more and more. But the key term here is that you have to define the VPC domain, you have to define the VPC peers, you have to define the member port, and here you can see that everything is marked. You can draw all these things in your notebook, in your copy. Then you have the VPC, then you have the VPC peer link, correct? So you can see this is the VPC. Will in the lab we'll go and define this VPC as a 200. Here in our lab, although we have very small uh, lab scenario, like you have 7K, 7K, and then you have 5K. Here you can go and define VPC 200, etc. But again, you can go down in a hierarchy. So from 7K, you can go to 5K. From 5K, you can go to the fix or the servers, where you can go and create the VPC. Again, the analogy is that you want to create the straight lines. You don't want complexity in a network. So what's the protocol behind the scene? The protocol behind the scene is CFS, Cisco Fabric Services Protocol, that will be used for state synchronization and configuration validation. Because here you are doing some configuration related to VPC, here you are doing some configuration related to VPC, who will be the primary, who will be secondary, who has the highest priority. According to the CFS protocol, it will go and synchronize the database. Let me show you the animated slide that we have. So let's try to understand that how we can go and build the VPC domain or VPC configuration. So first of all, you have to go and define the domain. So domain 10, domain 20, etc. Because different domains having different VPC elements, VPC member ports, VPC member channels, etc. Then you can go and define the peer keep alive. So these VPCs, they have to exchange their control messages. So for that, we have the VPC peer keep alive. Then we have to define about the peer link. So here you have the peer link, and here in the diagram, nice thing here is this, that you can see the colors as well. So when I am talking about VPC domain, you can see the color is light brown. Then green one is your keep alive. You may use management interface, or you may use dedicated L3 interfaces, correct, for the keep alive packages or messages. Then peer link, you can see this third number item is coming as a peer link. Then you can go and create the port channel. So you have the VPC, in our case that will be 200, etc. And then finally you can do rest of the configuration that you will find inside the lab section, correct? So lab section, all the 4 videos, when you watch, you'll find that how we can do a step-by-step configuration, and then how we can do the verification as well. Now coming back to verification, what is happening? First of all, you have to go and enable the VPC feature. So VPC manager will start, then VPC peer keep alive will get kicked off, means the control package message exchange will start, then peer link will come up, then it will resolve who is the primary, who is the secondary, then it will go and check the consistency check, means how many VLANs I am supporting, how many VLANs you have, what's the type 1 and type 2, those things in detail, correct? So you should not have a major configuration difference inside the inside both the peers. You should have a primary and secondary role type of configuration changes, that's okay. And then the peer link will be up for the data. The SVI brought up time, you can see VPC plus 10 second, the VPC's brought up time is SVI is plus 30 second. Great. So once our VPC will be up and running, you can go and use one very small but key command, show VPC. Show VPC will tell you good amount of information, and then you can read those information. If you have at least you will get the high level overview, means you're not getting 100% details, but you can see that 90% of the information it is giving. But again, if you want to do some troubleshooting, deep troubleshooting, then you have to use other commands. But you can see that as per our slide, it will give you 90% of the information, initial situation information, correct? So let's see. Here you can see that CFS communication with the peer, that's okay. Then we hear the keep alive, so it is telling that peer keep alive, we are getting peer is alive, then consistency check is successful, then VPC role. So all important things it is giving you, correct? Peer keep alive, CFS role, the peer information, the VPC role information from one command. And now here in the bottom you can go and read the important description related to all these output that we are getting here, correct? So let me clean this stuff. So if you want, you can take the snapshot as well, or you can pause the recording and I can see all this important information. So now what we are going to do, that in the upcoming section you have 4 videos related to the lab configuration and verification. Those are a little bit older videos, and maybe you will heard some fan noise as well, because working inside DC I created those videos. So go and complete section 1.2, and once you complete those 4 videos, then we'll start with section 1.3. Let us start the lab section. So what we are going to do, that we are going to perform the VPC configuration. Here you can see that we have 2 switches, Nexus 7K1 and 2, and the downstream switch is Nexus 5K1. Now in between this Nexus 7K switch, we have peer link plus one management interface, where we'll go and configure the VPC keep alives. All right, so let me go to Nexus 7K1 first, and inside 7K1 switch, we'll go and configure the VPC. So first of all, we need to go and enable the feature called feature VPC, because before enabling that feature, we can't do any VPC related configuration. So once I enable the feature, then first of all, I'll go and give the domain name. So here you can see that VPC domain, I'm configuring 200. And then we can go and check the management interface, because we want to configure the peer keep alive. So here we have one interface called MGMT0. I want to check that interface MGMT0, what's the IP address, because I need to go and give the keep alive address. So here you can see that my address is 113.4, so I'll go and give the address as 113.3. So let's go inside the VPC domain, and from here we can go and give the keep alive, so peer keep alive, and the destination is 10.31.113.3. Correct. So once we do this baseline configuration to Nexus 7K1, now I will go to 7K2, and inside 7K2 again we'll go and do the same configuration. So I have copied the feature VPC and VPC domain. Correct. Now once the VPC feature will get enabled and once we configure the domain, then we'll go and copy and paste the peer keep alive information. Now this time the keep alive information is that the remote site, that's .4, that's correct. Now once we have this very basic configuration, then again we can go and do the rest of the configuration. So first of all, I need to enable the feature called feature LACP, because to configure this peer link, so we have two interfaces, E/1 to 2, and here first of all I want to do the port channeling. So first of all, let's enable feature LACP, and over the interface, so let's take the interface 4 1 up to 2, that's the range, and then channel group 10 mode active. Correct. Now once we'll give this information, then what will happen, obviously the port bundle will start happening. The same configuration let's do inside Nexus 2, enable the feature LACP, go to that port range E4 1 up to 2, and then there also will go and give the channel group 10 and then the mode active. Now once we do this configuration, the next very important thing we have is to do the configuration related to port channel 10. So I am over port channel 10, making this as a switch port and then switch port mode trunk, because here we have to specify that this interface is VPC peer link. So we have to give the keyword VPC and then peer link, and the same information I have to go and provide under Nexus 7K1 and 7K2. Correct. So once we do this configuration, obviously, let me do that switch port and switch port mode trunk, and then the VPC peer link. So once we are done up to this point of time, then we can go and verify our VPC. So far what we have done basic configuration related to VPC. Here you can see that what's the peer status. You should see that this will come up. You can see the VPC peer keep alive status is alive, and the peer link should come up, and all those VPC states should come up. So now you can see that the peer status is peer urgency form good. We have our peer keep alive, that is alive. Correct. So we have this baseline configuration. So what we can do now, that we can stop here. Let us continue where we left off in the previous section. So we have done the configuration related to VPC over Nexus 7K1 and 7K2. In that section, we'll go and continue the configuration to the downstream switches as well. First of all, let's verify the VPC peer keep alive. So we know that our domain is 200 and keep alive is up and running. They are sending the UDP message is port number 3200. We can go and verify the keep alive things, that keep alive is up, since how long it is up, what's the interface, what's the time duration, what's the port. Now just to confirm the port number, you can see here in the slide that the keep alive, they are sending the UDP packets and the port number is 3200. So at this point of time, our VPC portion with respect to core switches on Nexus 7K1 and 7K2, they are good. What we want to check here next, we'll want to check the VPC role. So over Nexus 7K1, if I go and check show VPC role, and here you will see that it will show you the role as a secondary. You can see the role is secondary. Likewise, we will go to Nexus 7K2, and there we'll check the role. There the role should be primary. So show VPC role, and here you can see the role is primary. Now what I want here, I just want to change the role. Now to change the role again, I'll come back to Nexus 7K1. I want to make this switch as a primary. So I have to go inside the VPC domain first. Since the VPC domain is 200, and let me do some wrong configuration here. So I'll go and give the domain as a 100 is the wrong configuration that I'm doing. Later on, we'll go and correct this. And then I can go and give the role priority, say priority 1. Actually, lower is better. So that means this particular switch will become the primary. But before doing that, I should go and flap the peer link. Because if you do not flap the peer link, this role change will not happen. So for that, I can go and flap the peer link. So you can go to the port channel, and inside that port channel, we'll go and flap that port channel. Let's do that. So interface port channel 10, shut, no shut, and we are flapping the actually the peer link, because over this interface we have the peer link. Now you can see inside Nexus 7K1 it's showing primary, but operational it is secondary, because remember our VPC domain is wrong. That will correct later on. But let's continue and let's do the rest of the configuration. So we know that we have one downstream switch where you can see the interfaces. So from Nexus 7K1 the interface is E3/6. So I will go inside E3/6, and then I will go and do the LACP configuration or the VPC configuration. So let's do the VPC configuration, E3/6, and inside E3/6 we'll go and do channel group 200 mode on, and then we'll go inside interface port channel 200, where we'll make this as a switch port. Then we'll do switch port mode trunk, the same configuration more or less that we have done inside the peer link as well. Correct. But if you want to allow certain VLANs over the trunk, we have this facility, we can go and allow that. So once this configuration is completed in Nexus 7K1, inside Nexus 7K2, again, we'll go and check the E4/6, channel group 200 mode on, and then over the interface port channel 200, we'll make this switch port mode trunk. Once we do this configuration, then one key configuration is left. Again, inside Nexus 7K1 and 7K2 over this port channel 200, we have to make this as a VPC. So VPC 200 in Nexus 7K1, and again in Nexus 7K2 we have to do this VPC 200. So now the VPC related configuration to the core switches are done. Now we'll go to the Nexus 5K, that's my bottom switch, and inside Nexus 5K1 we have interfaces, and we'll check that interfaces, that those interfaces are E1/4 and 1/5. So I can go and check E1, 4 and 5 as a range, and channel group 200 mode on, and then I will go and do the configuration related to port channel. So here we have to do the normal configuration. We don't have to do much thing, but whatever. Hi there, thanks for your enrollment. We are in 1 minute ad break. In this break, I'm going to show you that I have so many courses uploaded over Udemy. And if you're going to enroll my courses, you will get 95% discount. Every month, 3 times. First week, mid of the month, and the last week of the month. I am sharing the coupons. If you go and use those coupons, then my courses related to CCNP, related to CCI, all those courses, you are going to get heavy discount up to 95%. You can see the prices are a little bit higher here, but if you go and apply the coupon, the prices will go rock bottom. So go use those coupons. Suppose if you don't have those coupons, then you can always ping me over YouTube. You can send me email. You can ask for those coupons. I will provide you that coupon. So get the coupon, get the discount. Some of my courses over Udemy, they are bestseller. Some of the courses are quite new, like SD-WAN automation, DNA automation, CCI data center 3.0. Those are the new uploads as well. So please go, continue your learning, take the coupon, enroll my courses, and study well. All the best. In this session, we are going to do quick revision that what we have performed in previous two videos. So now we have built the VPC, and you can see that we have VPC built here, and again we'll go and verify as well. But we have two Nexus switch and one downstream switch, and in between these Nexus switch we have peer link. In the peer link we have created the port channel. We have the peer keep alive link as well, that is in brown. That is one of our management MGMT0 interface. So let me write that MGMT0 interface. Now, so what we have done, we have created we have formed the VPC, we have created the peer link, we have configured the our management interface as a VPC peer keep alive link. We have configured the downstream switch as well. So let me open the slide that we have to quickly refer that whatever configurations that we have done, we'll go and verify quickly inside our PPT. Okay, so let me open that PPT, and we'll go and check all the terminologies that we have already discussed earlier in the previous section, that what is the peer link, what is the VPC peers, what is the member link, etc. So clearly you can see here it is defined that first of all the concept of VPC. So instead of triangle, we are creating the logical straight lines, and then we are overcoming the STP issues as well. Then we are defining the VPC peer, what is the multi-chassis ether channel, what is the VPC peer. Again, if we have dual VPC configuration, so one layer of VPC and again the second layer of VPC, the same type of configuration we can do to the second layer of VPC as well. Now, what type of hardware it is required and how we can go and connect our servers or end machine, that is presented here. Correct. Now, once we do configure our VPC domain, VPC peer, our VPC member legs, then what we need. So once you have everything set, obviously you will send the traffic, and the traffic flow will look like that. They don't have to uh, follow the triangle. They will think they are directly attached. So anything that will be attached to the end host in the bottom here, you can see that we have 2K fix, or maybe you have any switch, or maybe you have server. So the traffic originating from these locations going say from south to north, they will think that they are going in a straight line. They will not think that they have to cross like we are doing in STP, blocking and then forwarding, listening, learning, blocking, forwarding, etc. Again, we have to define the VPC domain, peers, member port, VPCs, and VPC peer link. All these configurations we have done earlier. Now, one key thing here is that what about if you don't have VPC members? That means there are chance that you are connecting a switch with the interface is a non-VPC domain. So in that case, the standard STP protocol will work in those scenarios. So VPC, once you have your VPC domain, it will work as your straight line type of thing. But if you go and connect any non VPC interfaces, it will your STP will come into the picture. Let's quickly revise. So what configuration we have done? You can see that we have done the configuration related to VPC. We have enabled the VPC. We have defined the domain. We have given the priority. We have configured the VPC peer link. And then finally, we have configured the downstream switch, that's the VPC domain as well. Correct. Now, once we have this configuration, obviously, let's quickly verify in Nexus 7K1 and Nexus 7K2 as well. We know that for port channel, we have used the port channel number, and you can see here the port channel number is 10, and then we have the member port channel, that's a VPC. Actual VPC is 200. At the moment, it will show you down because clearly you can see that VPC domain system ID mismatch, because in switch 1 I have given domain 100, other I have configured 200. We should go and correct this. So in upcoming section I will go and correct this. At the moment it will show you fail down, but we'll continue and we'll correct this in the next section, and then we are going to conclude. Hello everyone, this is the last inside the VPC configuration in this section. And in this section, we are going to focus more on getting back our VPC up and running, because we have done some wrong configuration inside that. We know that the VPC domain is actually 200 and we have configured as 100, and then we have flapped the VPC, correct? Now, doing this, what will happen that VPC will go to dual active mode. So what will happen here, you can see that inside Nexus 1, it is showing as a primary. And again, if you do shut, no shut, there is no change in this because anyway, the domain is not correct. So the strategy here that we are going to use is that first of all, we go and correct the domain. Once the domain will come up, then again, I will go and shut down the peer link just to see that what will happen. Correct. So you can see that VPC role, it is showing that in the first switch is showing primary. And if you go and check in the second switch, the VPC role, so let's check that role. And here it is secondary, and you can see clearly that dual active detection status is 1. So it has detected the dual active scenario. And in that case, what is happening that once it will detect that now you have two different control planes, so it will go and shut down all the member interfaces. Because if you have two different control plane because you are in dual active scenario, so in that case, it will start forming the loop. So this is one type of protection mechanism we have inside VPC. So now what we can do here that we can go and correct this scenario. All right. So let's start from Nexus 7K1. Inside Nexus 7K1, we'll go and give the VPC domain as 200. That's the correct one. And then again, we can go to interface port channel 10, shut, no shut. That means we are flapping the peer link. Now, once we flap the peer link, then you can see that the VPC will start forming, and you can see the status as well. It will take some time to do the convergence. After that convergence, you can see that the peer agency form okay, peer is alive. You have your VPC formed successfully. Again, the VPC, the member ports is showing that's down, but again, you can see that it will show you up. So it is taking few seconds to do the convergence. Once the convergence will happen, you will find everything will be up and running. Now what we'll do that we'll go to Nexus 7K2. Inside Nexus 7K2 as well, we can go and verify the VPC. So let's verify the VPC here. Also, you can see that it's up and running. And in the bottom, you can see that the VPC status that support channel 200 is also successful. Now, since it is converging, so it may take a few more seconds, but after the convergence, you'll find that things will be okay. Now again, we can go and check the role because Nexus 7K2 has role priority 3 to 67. That's the higher, and that's why it is showing secondary. If you go and check the role inside Nexus 7K1, you'll find that this will be 1, and that's why it's the primary. Now you can see clearly that this is the status is up, your port channels are up, everything is up and running. Great. So since everything is up and running, the next task that we want to do here is that I want to go inside the peer link. I want to do the shutdown. So let's do the shutdown. Now, after shutting down the peer link, you can see that we have moved inside the port channel 10. We are doing its shutdown. Now the VPC will again uh, go into the dual active mode. That means both the peers, VPC peers, they will think that they have the control plane, they are the masters, and then subsequently they will go and shut down their member interfaces. That's the one thing. Again, if you want to check more use cases related to failure scenario, you can go to the management interface, and management interface also you can do shutdown, and you can study the use cases related to that. The moment I'm not doing the management interface shutdown, because again it will break my entire VPC session. So let's not do that, but theoretically you should know that what will happen if your management link is down, what will happen if your VPC is down. All these things we should write it, and we should understand all these use cases because they are very frequently asked questions inside the interview. All right, so successfully we have completed our task. Let's stop here. Let us perform the lab task here. In our lab. So for example, we have switches, and these switches, so for example, switch 1 and switch 2, their interfaces are 0, 0 and 0, 1 both side. So we'll go and form the LSCP port channel. First, we'll try to form with the manual method. Method means you can make this on, and then we will use the LSCP as well. Even we have option for PAGP as well, but we'll focus on manual and LSCP. So let's go and do this. First of all, what I will do, that I will do the default for the interfaces, that we have E00 and 01, because we have done some configuration earlier and I don't want to do that here again. Means I don't want to have the old configuration, so I can go and default the old configuration. Now once I delete this, then I can go here and I can take the range of E0/0 and 1. Let me type it. So 0/0 and 1. And then we have this option of channel group. So for example, channel group, you can see the number is from 1 to 255. I can take 100 and then mode. Mode on means we are making this on, we are turning this on. So now here we can see, because this is the virtual device, so maybe we'll get some error. So port 100 invalid group slot number, etc, etc. Let's go back and try to make this 10. Okay, so this is the problem with the virtual switch itself. This is not the problem with the actual hardware. So if I use 10, it took the 10, and likewise I can do one thing, that show an interface E0/0. Let's copy and paste this configuration other side as well. So here interface range E0/0 to 1, and then I can paste the configuration, or we can go to channel group 10 or whatever we have. Let's see that we have created 10 and mode on. So 10 mode on. Now once we create this ether channel, then we have option that we can go and check show ether channel summary. Now here you can see that S stand for switched layer 2 and U stand for up. So we have this is up and running, and ports are in bundle. Now if you want to know detail about this, so we have option of ether channel, and then you have this option of detail. Even you can go and check the load balancing method as well. So I can go here and check this detail as well, and in detail you can check this information in detail as well. So here you can see all these detail options that we are getting. Now this is the manual method. Now suppose if I want to do this with the uh, automatic, or if I want to use any of the protocol, so in that case I should go to the interfaces. First we have the interface range, and then you can go and define the protocol. So this channel protocol is either LSCP or PAGP. That's a Cisco proprietary and the industry standard. Now because they are already in bundle, so we are getting this error. What I'll do here, that I'll exit here and I'll remove that group, or maybe we can go here and then we can remove that statement. So I'll do no here, and then I'll go and remove that statement from the other switch as well. So let's go to the range and paste this configuration. Removed. All right. Next, what we can do here, that we want to give this channel protocol as a LSCP. Then I can go and define the channel group, say for example 20, and then you can see the mode we have is active and passive for LSCP, auto and desirable for PAGP. But I want active, say for example active this side, and other side I can go here, and there again I can go and type say channel protocol is LSCP, then channel group is 20, mode is passive. So either it should be active active or active passive. So it will form the port channel. Now if I go here and check show ether channel summary, I can see the ether channel summary. I can see that now we have this, and they haven't negotiated everything, so that's why it was showing as suspended state. Let's see what is the actual code here. So waiting and S and N. So here you can see that you have layer 2 not in use and waiting for aggregation. So still the LSCP was not negotiated, and that's why it was showing that it is waiting. Now you can see that 20 has been formed and it is working properly. Correct. So this is the way that we can go and bundle the ports. If you want to see more things related to this, so still we have the option that we can go and check the protocol and then enter. So here you have the LSCP protocol, you have group 20, that mode is on. So like that we can go and check this. Now suppose if we have some issue that is keep coming and coming and coming, so you have the option to do the debug for LSCP. Once you do the debug for LSCP, then you have to check that who is the sender, who is the receiver, etc, etc. Okay, so you need to understand that this debug how it is working. And if you go here and oops, so I can go here and I can debug LSCP events here as well. I can go to conft and monitor, or let's see if I can monitor over the screen, otherwise I have to go and check the logs. If any problem will be there, it will start sending these LSCP related negotiations problem that we can go and check. So I think terminal monitor is the command. Console already monitors. All right. Now if I go here and do any type of if any type of issue will come, so let's see. And channel protocol is PAGP. So if we create any issue here, and then if we verify this, we can see some problem. So I'll do one thing, no channel protocol LSCP, and then you can go and check the debug. So this is the way that we can go and verify the debug as well. Remember that whenever you are creating the debug, it's not recommended that you should do in the production network. You should have the maintenance window, or if the issue is major, you can take Cisco TAG online, and then you can do the troubleshooting, deep dive troubleshooting. Hi there, thanks for your enrollment. We are in 1 minute ad break. In this break, I'm going to show you that I have so many courses uploaded over Udemy. And if you're going to enroll my courses, you will get 95% discount every month, 3 times. First week, mid of the month, and the last week of the month. I am sharing the coupons. If you go and use those coupons, then my courses related to CCNP, related to CCI, all those courses, you are going to get heavy discount up to 95%. You can see the prices are a little bit higher here, but if you go and apply the coupon, the prices will go rock bottom. So go use those coupons. Suppose if you don't have those coupons, then you can always ping me over YouTube. You can send me email. You can ask for those coupons. I will provide you that coupon. So get the coupon, get the discount. Some of my courses over Udemy, they are bestseller. Some of the courses are quite new, like SD-WAN automation, DNA automation, CCI data center 3.0. Those are the new uploads as well. So please go, continue your learning, take the coupon, enroll my courses, and study well. All the best. In this section, I will go and complete tagging, trunking, the static path binding, and various type of STP protocol. So let's go and complete these topics. So here you can see in the diagram that when you have two switches, and when you're connecting two switches, obviously you want to allow different VLAN inside that. So that's why the distribution layer switch and the access layer switch, we have 802.1q trunk. Now what is trunk, which type of trunks we have, that I'm going to discuss. So let's first understand that what is VLAN and why we need VLAN. Say, what is the default nature of a switch? We know that by default, whenever a switch there and whenever it receives a frame, so for example, you haven't enabled any type of VLAN, or you're not working, created any VLAN to the switch. So whenever the frame will come and hit to the switch, it will broadcast that particular frame to all the available interfaces, correct? And in this way, number of collision domain or number of collision will increase. Rather than, what you can do, that whatever switch you have, you can divide that switch into a smaller group, and that smaller group is nothing but the virtual LAN. So this LAN segment you're dividing into a smaller group, that is, if for example VLAN 10, VLAN 20, VLAN 30. Now in that case, when a request will come, it will only broadcast it to that particular group, because different VLAN, they have the logical boundary. So VLAN is nothing but a logical boundary to reduce the broadcast domain. Plus, when we are creating the VLAN, uh, by default, we are providing some more security as well. So VLAN 10 and VLAN 20, they will not communicate until unless we have a router in between, that we can use router on a stick concept, or maybe the switch, they are supporting SVI. So they need some sort of gateway to communicate across the VLAN. So here you can see in the diagram that you have VLAN 100 and VLAN 200. They are purely in different IP subnet. So two different IP subnets or two different broadcast domains, they will communicate only if they know how to reach to the gateway, or they have to cross the gateway or the boundary. Now how to create the VLAN, it's very easy. You can go to the global config mode. You can give a VLAN and the number, and then you can define, then you can give the name. So VLAN number and name, you can define like that. Now here you can see that we are supporting although up to 4K number of VLANs, means we can create up to 4094 VLAN starting from one. VLAN 1 will be default, but this number of 1006 to 4094 will be supported in transport mode, means they will be supported inside extended VLAN range. You can go and create up to 2005, where 1002, 3, 4, and 5, they are reserved for token ring and FTDI purposes. Okay. So we can go and create the VLANs. It's very easy to create. Let me quickly log into the switch and let me show you that how you can create the. So here I am inside the switch, and what I can do, I can go and create, say for example, VLAN 100, and then I can go and give the name as, say for example, servers. Then we can check the VLAN. So here you can see that you have VLAN 1 by default, and all the interfaces by default they are part of that VLAN. Then you have the reserve VLAN 1002 to 1005. But again, you can go and create the VLAN. So for example, I have created the VLAN 100, and I should exit, and then we can go and check that VLAN. So here you can see that now you have the VLAN 100 created here. I will not add any interface, but if you want, we can add the interface as well. So for example, any of the interface, show interface brief. Let's see that what available interfaces we have to this particular switch. These are the interfaces that I can see here, and if I can check the interfaces and the summary, so now you can see that you have these interfaces because this is the virtual switch. So you are seeing less number of interfaces, but I can go to any of the interfaces, for example, 1/1, and then I can go to switch port mode access. We'll discuss about this mode access and trunk, and then I can go and assign switch port access VLAN 100, and then I can go and check about this particular interface, that is show interface E11, and we have this option of VLAN. Even we have option for the trunk as well. So this mapping will not work, but if we go and check show interface E11 and then trunk, so here you can see that the encapsulation is negotiated. This is non-trunking. What is trunking, what is non-trunking, we'll see. The number of VLAN allowed over this interface is VLAN 100 that we have created. So like that, we can go and check it. So here you have the command, and you can check show VLAN that just now we have checked. Now, if you want to assign that particular VLAN to the interface, you can go and use switchport access VLAN 100. Again, you can go and check show VLAN. So 100 is assigned to this particular interface. Now, what type of ports we have that we can assign to VLAN? We have access and we have trunk. So what does it mean? It simply means that suppose if we have switch and that switch is connected with the terminating device, means where you are terminating the network. So that particular interface you can put inside access VLAN. Say maybe access VLAN 100 or 200 or 300, etc., etc. And that's the reason in corporate network we are creating certain type of VLANs. So for example, VLAN name data, VLAN name wires, VLAN name sales, HR, etc., etc. So terminating devices generally we are assigning to the access port, but where you want to connect the other networking devices and you want to extend that access VLAN throughout the network, or you want to propagate that VLAN throughout the network. So whenever you're connecting a networking device to other networking device which is non-terminating, that you want to extend the network, so at that point you want to create the trunk. So trunk simply means that can allow multiple access VLAN, or that can allow multiple VLAN. Access means they are part of only one VLAN. Later on we'll see that we have different type of trunking protocols. So here you can see that rather using three different cables over one interface, once you enable the trunk, you can allow different VLANs over that. So for example, VLAN 100, 101, 102. We have trunking protocols. We have ISL, that is Cisco proprietary inter-switch link, and then we have industry standard, that is 802.1q. Now in this diagram, it is quite clear that if you have terminating devices, so these terminating devices, they are part of same VLAN or a VLAN. Here you can see VLAN 100, here you can see VLAN 200, here you have VLAN 200, like that. And suppose if you want to extend or you want to pass multiple VLANs over the trunk link, then you can go and allow those VLANs over connecting networking devices, correct? So either we can use ISL or we can use 802.1q. Here we have dynamic trunking protocol as well, which is something you can think that this is uh, dynamically negotiating the trunk or dynamically negotiating two switch properties, although we have option to do this configuration manually as well. So how we are going to do this manual configuration, how we are going to do it dynamically, I'll show you in upcoming slides. Now the characteristic of 802.1q, that is now the standard, and even Cisco also uses 802.1q, is because this is lightweight rather than this ISL that is encapsulating entire frame. 802.1q, the feature or the improvement it has is that they are embedding. So here you can see that they are embedding 4-byte VLAN tag. So they are adding some tag to the frame, and once they add the tag, then the default size of the frame will increase up to 1518 because they are adding 4-byte of frame, and then it is supporting maximum 4096 VLAN. Now how it look likes? It look like this. So you have the frame. When you add 802.1q VLAN tag, inside VLAN tag itself, you have VLAN ID 12-bit, and that's the reason it is supporting 4096 VLAN, because 2 to the power 12, if you check this number, then you will find it will be 4K, correct? So 2 into 2, if you do 12 times, we know that uh, uh, you can do the math, so you'll find that it is 4K. Apart from that, we have priority bit, we have the protocol tag, we have some bit as well, that is the canonical format bit. Okay, so we have just a overhead of 4-byte, and it is propagating the number of VLANs through this tag. So let me quickly log into the switch, and I'll create a VLAN 200, and then in between two switches, I have switch 1 and switch 2, I will enable the trunk. So let's do that. Mode trunk. And now it is telling that, see, this command is rejected because the trunk encapsulation is auto. If you want to do it manually, you have to do switch port trunk encapsulation. And here you can see that we have .1q ISL negotiate. So I'll do .1q and then switch port mode trunk. Okay, and what type of VLAN you want to allow? Switch port trunk allowed VLAN, say 100 and 200. Although I haven't created the VLAN 100 and 200, I want to create 100 and 200, and I don't want to add this VLAN 10. So I can do remove 10. Okay, now we can go to the interface, say E0/0 and even 0/1 as well. So what command we are using? We are using switch port. First of all, switch port trunk encapsulation .1q. This is that manually I am telling that encapsulation is .1q. Switch port mode is trunk, and we are allowing VLAN 100 and 200. Now same thing I can do to this side as well. I can go to interface range E0/0 to 1, and then now we can go and check show interface E0/1 trunk. This is one very good command. So allowed, here you can see that over E01 the allowed VLAN is this and this. The VLAN allowed over certain interface is this. We can go and check show and interface E0/0. So this is the command that we are working at the moment. I haven't created VLAN 200 to other switch, so I should create that also, but just for demo purpose. This is solving the purpose. So this is the way that we can go and create the VLANs, and then we can create a manual trunking, or we can do manual trunking as well. Hi there, thanks for your enrollment. We are in 1 minute ad break. In this break, I'm going to show you that I have so many courses uploaded over Udemy. And if you're going to enroll my courses, you will get 95% discount. Every month, 3 times. First week, mid of the month, and the last week of the month. I am sharing the coupons. If you go and use those coupons, then my courses related to CCNP, related to CCI, all those courses, you are going to get heavy discount up to 95%. You can see the prices are a little bit higher here, but if you go and apply the coupon, the prices will go rock bottom. So go use those coupons. Suppose if you don't have those coupons, then you can always ping me over YouTube. You can send me email. You can ask for those coupons. I will provide you that coupon. So get the coupon, get the discount. Some of my courses over Udemy, they are bestseller. Some of the courses are quite new, like SD-WAN automation, DNA automation, CCI data center 3.0. Those are the new uploads as well. So please go, continue your learning, take the coupon, enroll my courses, and study well. All the best. Next, we have to understand about the trunk and dynamic trunking protocol, DTP. We know that we can create the trunk or to pass multiple VLANs across two different switch or inter-switch link, we can create the trunk. We have option that we can do it manually, and then we have option that we can do, or we can use dynamic protocol as well. So for example, if you have an interface 2/24, and if you run this command switchport mode trunk, first of all, it will throw an error. It will tell you that first you do the trunk encapsulation protocol, or run the trunk encapsulation protocol, either ISL or .1q. So if you do that, and suppose if you have two switches connected back to back, say I have one switch here, another switch here. Here if I do ISL inter-switch link, and here I do .1q, then obviously they will not form the trunk. So both sides we should give the same protocol, same encapsulation in other words, and then only they will form the trunk. So for example, if I give same encapsulation, so for example 8.1q or 802.1q or .1q, etc., then they will form the trunk. Now here we have the option. Either we want to do it manually, or we want to use the DTP, dynamic trunking protocol. So for that case, what you can do, that you can go to one side and you can do encapsulation negotiate. The full command is switchport trunk encapsulating or encapsulation negotiate, but they will prefer ISL. They will not prefer 802.1q due to these other Cisco switch. So they are going to prefer ISL. Better we can do it manually as long as possible. Now, once you have multiple VLAN and you want to allow it, you have option switchport trunk allow VLAN, and then you can give number of VLAN or range of VLAN. If you want to remove, we can remove that also, that we have done in the previous section where we have removed one VLAN, we have allowed certain VLANs. Now with this TTP dynamic trunking protocol, that is again the dynamic way to create the trunk. Again we have options. So this DTP has two modes to dynamically decide whether the port become a trunk or not. We have dynamic desirable, and then we have dynamic auto. So here you can see, if I go to certain interface and if I type switch port mode dynamic and question mark, I will show you in this in the switch as well. So then I have option dynamic desirable, dynamic auto. Now we have one long list that if two different switch, what mode they are running in and how they are going to initiate the trunk. So for example, you can do manual, you can do with help of DTP automatically. So manually, if you are making trunk, obviously they will form the trunk. One side trunk, other side is dynamic desirable. Dynamic desirable means you are sending the packets to form the trunk, means you are sending the negotiating packet. But dynamic auto will not send. So we'll see that. One side trunk, other side is dynamic auto. They will form the trunk. If one side you have dynamic, say desirable, other side dynamic desirable, they will form the trunk. So all these cases, they are forming the trunk. And suppose if you have dynamic desirable and dynamic auto, they will form the trunk. But if you have dynamic auto, they will not form the trunk, because both these sites, they will expect that they are ready to listen the frames, but they are not actively sending the frames. So that's why they will not form the trunk. Now suppose if you want to disable DTP, you have option switch port no negotiate. Correct. So in that case, we are not using this DTP to form the trunk. And again, you have the summary slide, whatever we have discussed here. Now, what are the troubleshooting option we have? Suppose if you're forming trunk and this trunk is not coming up. So you should check these things like what's the trunk mode, ISL versus 802.1q with respect to frame tagging protocol. So this is trunk mode will be, you should check what is the mode of the interface, say access or trunk, etc. Then the tagging protocol is ISL versus 802.1q. Then do you have a native VLAN mismatch? Suppose one side you are allowing 100 and 200, other side you are allowing only 200. Do you have any VTP domain configured? We'll see that VTP in the upcoming section. And that is only true when you are using DTP to negotiate the trunk. So these things one by one you should go and check. Then we have one very important command here. Here you can see in the bottom that show interface name and switch port. This is actually very important command included with show interface trunk. So these two commands are there for verification, and both side you can go and run, means both side means both the switch. You can go and run this command and you can check that which VLANs are allowed, which protocol is running, what is the mode of trunk, etc. So let me quickly go and log into the switch and we can do some of the verification commands. So I am inside the switch, and if we go and check show interface description, we are just checking that switch 1 and switch 2, which interfaces they are using. So E00 and E01, these are the interfaces that is connecting to switch 1 and switch 2. And if you go and check show interface trunk, one very important command. So here you can see that E00 and 01, they are allowing these two VLANs, although the management domain it is showing only 100. Why? Because if you go and check show VLAN, you have only one VLAN. So what I'll do, I'll go and create VLAN 200 as well, and name I will give, say for example, clients. Now if we go and check show VLAN, we have server and we have client. Although we haven't assigned that to any of the interfaces, now we can go and check interface trunk, and now here you can see these VLANs are coming. Okay, all right. Now the status, you can straight away see that 00 and 01, they have status of trunking. Native VLAN is VLAN 1. The mode is on. Okay. Now show run interface E0/0. This is the configuration we are using. If I go to other side, so interface and then trunk 100, 200, because we haven't created any of the VLAN, so it is not showing anything. Mode is on, encapsulation is at 02.1q. That's okay. Then I can go here. Also, I can create VLAN 100, name servers, and then VLAN 200, name clients. And then we can go and check show interface trunk. So you'll get the same result. Now next very important thing that we can check, show interface E0/0 and then the switch port. This is actually a nice output that will give you detail about VLAN and trunk. So administrative mode is trunk, operational mode is trunk, encapsulating 802.1q, negotiating of the trunk is on, access mode VLAN, that's the native VLAN, is 1, that's okay. Tagging is enable, voice VLAN is none. We are not using private VLAN at this point of time. Trunking is enable, we are passing 100, 200. Pruning is there, means there are some default options as well. All right, so what we can do now at this point of time, we can check all the DTP option. So if I go to interface E0/0, and once I am inside switch port, you can see that what options you have. So you have a no negotiate if you don't want to, or if you want to turn off DTP, you can use no negotiate. Then if you want to check mode, and then you have this dynamic, you can see auto and desirable, and we have seen that list. So DDDD one side and DDD other side, that will form the trunk. If you have auto both the side, dynamic auto, they will not form the trunk, and vice versa. Okay, so this is the way that we can create the trunks, and we can verify as well. All right, so let's stop here. Now let us discuss more and build the basic fundamental knowledge about the ACI. So before understanding the glue between the, say, underlay, whatever hardware I have in the underlay, and the overlay, what type of tenant and logic I have, so physical and logic, physical hardware and the virtual network, let's understand few of the things before moving further. So what I want here, that let's discuss little bit about the construct of the ACI. So one side you have the tenant. So what I have my virtual network, and here I can have my VRF or context. I can have my bridge domain, something like VLAN. Sometimes we are thinking about broad VLAN or VLAN, anycast VLAN or something like that. So VLAN is spread it across the fabric, and this having the subnets where I can define the gateways. Then we have something called, say, application profile. We have application endpoint groups. Inside application endpoint groups, we have the endpoint. Then we can have contract, and inside contract we have the subject. And then finally we have something called filter, very much similar to the access list or something. So inside the subject I can call the filter. Now this contract I can apply across or in between two different endpoint group. So maybe if I have endpoint group associated with web, and I have endpoint group, say for example associated with app, in between I can apply the contract, correct? This is again the logical network, but it is coming on the top of access policy. And if you are creating the access policy, what are the things you have to create? So you have to create the interface policy first. Inside the interface policy, you will define what is the CDP, what is the LLDP, what is the STP, what is the MCP, what is the link speed, etc. So you have so many things. We'll see. We have slides for that. Once you have the interface policy, then you can group that interface policy inside the interface policy group. That is again very important. So what is this interface policy group? I'll write on the top here, somewhere here. This interface policy group, interface say policy group, you can have, say for example, AAEP here, and then you can define that what VLAN pool. You can define that what domain, etc. Correct? So domain means sometimes in switch we can tell, okay, the switch port mode access or no switch port. Either it's a L2 or L3 domain. VLAN pool we are associating, okay, VLAN 10, VLAN 20, VLAN 30, etc. Then once you have the interface policy group, you can call that interface policy group inside interface policy profile, where you have to give the interface selector. So you are calling this, say this is for example 1, this is for example 2. Inside 3 you are calling 2, automatically it will call 1, and then finally inside number 4 we are creating the switch profile, and then everything will be attached. Correct? Remember this AEP, something that's the glue between the access policy and the tenant. Now understanding this flow, now we can move further and discuss more about this. So now at this point of time, we understand what is the endpoint. Endpoint is something that may be VM, that may be physical system, where you are getting the MAC address, or where you are getting the IP address, or you have some ARP request. So these things under the fabric can reach to their spine because they have maintaining the databases, the COOP databases. We'll learn more about these COOP databases and the message exchange in the upcoming section. But yeah, you have the endpoint. These endpoints are connected with the leaf. So I have the leaf, and then leaf is connected with some other third switch, maybe Catalyst 3K or something, where you have the endpoints. They are carrying the MAC or IP or the ARP. Where I have the leaf and a spine, they are learning those, means the leaf will send message, so my spine will learn those addresses, and then the exchange of the traffic or traffic communication will happen, etc. These things will happen. So I want to draw this diagram one more time just to make this little bit easier to understand. So I have leaf 1 here, and I have say endpoint 1. Then it is connected with, say for example, a spine 1, and say for example a spine 2, and then here I have, say for example, leaf 2, like this. Now we need to understand this, that if we are in the same subnet, same EPG, so whatever IP is irrelevant in ACI. Means if they are same IP address, if they are different IP address, doesn't matter, until unless they are the same EPG endpoint group or different EPG. So if they are same EPG, no contract is required. At the moment you think contract as a filter rule. So no filter rule required within the same EPG. That's the golden rule we have in the ACI. By default, it is not required within the same EPG. But if you have different EPG, either with the same subnet or with the different subnet, contract required. Okay, so we have actually only two use cases here listed, that you have the same subnet, or if you have different subnet. If you have same EPG, the contract is not required But if you are in different EPG, either it's the same or the different subnet, contract or the tuning rules or the filter rules require. Okay, so this is actually the key point we have, and one by one in these slides we'll understand more about these points. Before moving further, we have again this particular chart. So this is what? This is your interface policy. So your interface policy you are calling where? I'm calling inside interface policy group. Now this interface policy group, they have access entity profile or attachable access entity profile, physical domain, either it's L2 domain or L3 domain. Now what's the VLAN range, VLAN pool? You define these things. So this is something, say point number one, this is point number two. Then you can see that you have interface profile, where you have interface selector, where you calling the interface policy group. And finally, you have the switch profile. So these are the logistic we have in this flow, and we have to understand both the thing. So not only you are understanding the physical connectivity, so what is within the fabric, this is again become irrelevant. What is inside the fabric, this is one time setup. What type of rules and policy you are creating here. So now I told you this is a mix of data and control plane, this particular diagram. So we need to isolate that, okay, since you are telling that SDN is something that I am decoupling the control plane and the management plane, but you will find that since the evolution of SDN, it doesn't mean that you have only, say for example, control plane, you have only, say for example, data plane, but nowadays we have management plane also. In ACI, this is from day one. We have orchestration plane as well, so I will not go inside the orchestration plane, or maybe something, some software hosted over cloud from where I can go and configure, deploy all these private and public cloud, etc. But the control plane and data plane we have inside this, say, spine and the leaves, and the data plane is nothing but the VXLAN. So what's about the control plane? What are the control protocols we have? So we have control protocols like COOP, Council of Oracle protocol. We have ISIS. In between these leaf and spine, I have layer 3 reachability. So that's why they are doing something called equal cost multipathing type of thing. At the moment, these devices, they want to form, or they want to communicate actually from one place to other place. We'll come to know that these leaf, they are termed as a VTEP, VXLAN tunnel endpoint. They are termed as a VTEP, VXLAN tunnel endpoint. They will form the dynamic tunnel, and then the communication will happen. Now it seems like, oh, how easy is this? So you have your endpoint, and once endpoint will come to this interface, he will send the message, oh, it's fine, this is the message of this endpoint. You learn and store inside your COOP database. Because this spine is working as a route reflector, he will reflect those information to all the leaves inside the infra. Now I can't tell this that this is a type of route reflector, but you can think like BGP type of route reflector. So once the spine has the information, he will send those information to all the leaves. So this leaf also have the information of this particular endpoint, and then if they want to communicate, they will form dynamic tunnel, VXLAN tunnel. So this particular VLAN that I have here associated with this port, this will become locally significant. Why? Because this VLAN will automatically map inside the ACI. That's the feature we have. So that will be automatically mapped with the VNI, some VXLAN network interface. Here also they will map with the VNI. These are the L2 VNI, and then if it is L2 traffic, they will communicate. Again, it seems like it's a very straightforward thing that I connected the device, it is working, but what Cisco has done, that they have optimized the data plane behind the scene, plus so many optimization and tuning inside the control plane and the database learning or the endpoint database learning also over the spine. So these things has happened. So let's just stop here, and next section will start from here only. We'll discuss more about the policies and the contracts, because it's the same EPG, same type of subnet, so obviously we don't need contract, but we'll discuss more the basic steps in the upcoming sections. In the bare metal lab, we are going to discuss that, okay, if we have the connectivity in say normal Nexus world, how you can going to do the configuration, and when you are doing the connectivity, so from NX OS normal traditional network, if you are going inside ACI, then how you are doing the connectivity. These are the things we are going to discuss in this, and in later section, later video recording, you'll see that inside ACI how we can configure. We know this thing is very easy in the Nexus world, that you can go to the interface, you can make the switchboard, maybe mode access or switchboard trunk allowed VLAN, and you can allow whatever VLAN these endpoints or these host belongs to. So let me show you one slide I have. So for example, you have your leaf switch connected with say uh, any blade server, for example UCS C series, where you have the hypervisor and you have your ESXi hosted. On top of that you have your virtual machines or guest operating system. So how it is in normal NXOS or traditional network, we have what switches are connected with ESXi. So for example, switch 1. What are the VLANs for my ESXi host? So for example, this is the range of the VLAN for the ESXi host. How do we send the right VLAN to right place? Then we are using the allow VLAN. Remember, all these things are related to the traditional or the Nexus OS. Then what interface configurations you have? So channel group mode active, what is the speed, what is the duplex, what is the CDP, LLDP, etc. Those configurations. Then finally, what is the which interface is connected with that particular server. So this configuration we used to do from long time, but now if you convert this configuration inside ACI, then how it will be. So the first and second thing is related to what objective we have and how we can connect with Nexus OS. In the bottom you have that how you are going to do that thing inside the ACI. So inside ACI, the VLAN and the VLAN number, it will be inside VLAN pool. So I can go inside VLAN pool, I can create that object for VLAN pool. Then switch port mode trunk and the allowed VLAN, I have to create the domain. So is it L2 domain or L3 domain or any other domain like that? But those things you can create from AEP. So there the logistic is that you go to interface policy. Inside interface policy, you have to create these things. So next, what interface and what interface policy, like link label, CDP, LLDP, port channel, MCP, etc. So the first step is the interface policy. Second is interface policy group. Once you are inside the interface policy group, then you can define these things. So inside that, actually you are calling interface policy. Along with interface policy, you are calling AEP. Inside AEP, I can define the domain and I can define the VLAN pool. Okay, so I can define the domain, I can define the VLAN pool. Then once you have those things, so what is the order in ACI? So first of all, what are the things you are defining? First of all, you are defining the interface policy, one. Then you are defining the interface policy group, where you have the AAEP, where you have the domain, and where you have the VLAN pool. Then third, you are defining the interface profile. Interface profile, you are calling the interface policy group. and here you have the interface selected. Once you have the interface profile, finally you have to go and create or call all those things inside the switch profile, and that's it. Your access policy related to southbound or your access policy related to endpoint will be done. Okay, so this is actually important slide. What you want to do, how you can do in Nexus, how you can do in ACI, what are the terms where it is fit in, you can have a look and correlate with. Alright, so let's stop here. Alright, let us perform the task here inside the ACI. So the lab that we have seen, the lab setup, the same type of configuration I am going to do. Whenever you are going to do the configuration, remember you have to start with, say for example, interface policy. There we have different type of interfaces and policies related to that. Then you have interface policy group where you are going to call this. But here you can define the AAP, what is the VLAN pool, and what is the domain. Then you have to create the profile related to interface and related to switch. So policy and profile, these two things we have. And if you go and create this step by step, so all those options you will get automatically inside the ACI fabric. So let me go inside the interface policy. You can see I have the policies. I can go and create a link label policy. So suppose 1 gig is my policy. Then I can go and select, say, 1 gig, submit this. I have one policy that is 10 gig initially created, no problem. Likewise, I can go and create, say, CDP policy. This is CDP policy. CDP should be on. You can see the administrate is enable. Likewise, I can go and create, say, LLDP policy. So LLDP policy, this is enable. The RX and TX are enable. So I have this LLDP policy. You can see that we have long list of policy like fabric channel, priority flow, slowed rain, port channel analytic, port channel member, spanning tree, storm control, MCP. We have so many policies. The good thing about the ACI is that once you create all these policy classes or policy template, then I can reuse it n number of times. So next what we have, next we have policy group, and inside this policy group, I want to create access port policy group. I'll give the name, say, my policy group, and inside this my policy, I can scroll down and then see you can call all those things that you have created. So for example, 1 gig, then we have this CDP policy, then we have this LLDP policy, whatever we have created. And if I scroll down, here you can see that we have the glue as well. What is that? The attachable entity profile. Go click there, attachable entity profile, and you can create the profile. The other option you have that you can go here to the global policies. Inside there also you can create the attachable entity profile. You can go and create the pools as well. You can go and create the physical and the external domains as well. From here also you will get all those options because all these things are linked together, correct? So I'll give the name, say, my AEP, and then here what's the domain, what's the VLAN, etc. So I'll go ahead and click domain, and I want to create the physical domain. Update. Now this physical domain is by default connected with this particular VLAN. So now if you want to change this, then what you can do at the moment, let me go here and let me cancel this. So what I can do here, that I can cancel this physical domain and cancel this. I do not write this rather than what I can do, that I'll remove this submit it. I'll go in the bottom here. So for example, I can come to global policy, and inside this global policy, let me delete this first because it is associated with physical domain. Even you can edit as well, but I'm showing you that you can delete it. I can go here down to the physical domains, and physical domain, I will right click, create physical domain. I'll give the name, say my physical domain. Then I can select the VLAN pool. I'll create my, see, I have my VLAN pool. Let me show you that how we can create. So I can create my VLAN pool, and the range I will give, say, static allocation for that. The static allocation, for example, I'll give from 100 to 500. Okay, submit. So now I have the physical domain and the static VLANs binded with that. This my physical. Now I will go to the global policy. So I have my global policy, and inside this global policy, I can give the name, say my AEP, and inside this now I can go and call the domain, that is my physical update. You can see the VLAN 100 to 500, correct? And then I can click next, I can go next, and I can finish it. So once I have this, then I can go to my policy group. Inside that my policy group, I can scroll it down. I have this AEP. I'll go here, I'll select my AEP, and I'll click submit. Now this VLAN, this policy group, they are calling all the policies plus my AEP. My AEP will call the physical domain with the given VLAN pool that we have created. So now you can see the logistic. Although if you do this first time, you'll find it a little bit difficult, but once you have the proper understanding that what you are doing with respect to Nexus CLI and Nexus configuration, then it makes sense. Now, what is the next thing that we need to do? We need to go and create the interface profile. So I'll go here and create the interface profile. Uh, Interface profile I want to create for, say, for example, port number 29 I have. Better I'll give some better name. So this is, say, for example, leaf 101 129. I'm giving the interface profile name like this, but you can give the name like this also, 1/29. But if you give the full name, then suppose if I give this name, because naming is also very important in the ACI. So with the name also you can understand where it is. So if I give the name like this, then 1-29, I can use whatever leaves I have. If I have same type of 1/29 configuration, correct? So 1/29 and the interface is 1/29. Then I'll call this my policy. Now you can see the power of the templates or power of the objects. This my policy I can call to n number of interfaces. Click OK, submit. So now I have one leaf profile, and I want to create one more, because if you see the diagram, you'll find that leaf 101 was connected with 1/29 and leaf 102 was connected with 1/21. Again, I am calling the same profile, submit. So once I have the interface profile, then what is the final step we have to do here? I have to go inside the switch policy and then the switch profile, create the profile. Here I can give the name, say, leaf 101 129, because now we are referring the switch, which particular switch I want to assign that interface, correct? So first of all, that is 101. I can click here, update. I can go next. Then clearly I can go and select 29 and finish. So now it makes sense that 1-29, we are selecting 1-29, correct? Like that, I can go here and 102, 121, because this time we are going to select 1/1-21 or 1/21. Here I can give port selected, and then this is something 102. I can click update, go next, and this is 1/22, finish, and now we have the proper configuration. So this is the configuration, say, related to the access policy. Next, what we have to do, we have to go here, and I want to create a new tenant. So suppose this tenant is bank ABC. Bank name is ABC. So bank ABC, one of the customer. The VRF is say bank one. Submit. Now I can go inside that particular bank and I can create what are the things now we have to create. So now we have to create the things related to, say, application profile, endpoint group. In our case, everything is web. So I have endpoint, web related endpoint, IP say 10.10.110, and other is also say 10.10.1.11. Because they are in the same endpoint group, so we do not need any contact in between them. Then we'll go and define the bridge domain. Inside bridge domain, we'll see what options we have. The subnets, if we want these guys, they have the subnet, for example, 10.1.1.1/24 here. And then we need to do some sort of static binding, because the overall topology that we have is we have say leaf 101, we have leaf 102, they are connected with a spine, but the endpoint is 1/29 and 1/1/21. Here I have the web endpoint. Okay, so let's stop. Hi there. Thanks for your enrollment. We are in 1 minute ad break. In this break, I'm going to show you that I have so many courses uploaded over Udemy. And if you're going to enroll my courses, you will get 95% discount every month, 3 times. First week, mid of the month, and the last week of the month. I am sharing the coupons. If you go and use those coupons, then my courses related to CCNP, related to CCI, all those courses, you are going to get heavy discount up to 95%. You can see the prices are a little bit higher here, but if you go and apply the coupon, the prices will go rock bottom. So go use those coupons. Suppose if you don't have those coupons, then you can always ping me over YouTube. You can send me email. You can ask for those coupons. I will provide you that coupon. So get the coupon, get the discount. Some of my courses over Udemy, they are bestseller. Some of the courses are quite new, like SD-WAN automation, DNA automation, CCI data center 3.0. Those are the new uploads as well. So please go, continue your learning, take the coupon, enroll my courses, and study well. All the best. So let's start with RSTP, that is Rapid Spanning Tree Protocol. Now it's very good that if we know the other spanning tree protocols as well. So for example, it's good if we know STP, PBSTP, PBSTP plus, and then RST, and then RSTP, and then MST. But I'm going to revise those spanning tree protocol, at least the core behind the spanning tree protocol methodology. What exactly happening when we are talking about the switching network or switching architecture? So in that case, to prevent from the loop, we are running actually STP. So suppose if you have three nodes connected like this, like a triangle, suppose switch A, B, and C. Now here you can see that if you build your network like this, obviously uh, you will find the loop. So frame will be looped across this triangle. So uh, now again, you may think that why we are creating network like triangles or looped network. The answer is for redundancy. We are creating such type of network so that can provide us redundancy. So for sake of redundancy, we are creating such type of network. So for example, if one link is down, still you have one backup link, or maybe you have other links as well. So two link is down, still you have one link, etc. So for sake of redundancy in a switched network or in layer 2 network, we are creating loops, or we are at least creating such type of network design. Now the question here, second question may be that, okay, since we are creating the loop, then what is the loop prevention mechanism? And then the STP is the answer. Spanning tree protocol is loop prevention mechanism. What it is doing that as per the priority, one of the switch will become root, and then obviously you have second root and non-root. But what is happening that whatever interfaces that is going towards the root, they are termed as a root port. So you have a root port, and whatever interface you have in front of root port, those are termed as a designated port. So you have DP and then you have RP. Now what about those switches where you have least priority? They are not root, they are not secondary root. So in that case, they will go and check the priority. If priority is same, then they will check who has the lowest MAC address. So one of the interface will treat as a blocking, BLK, say BLK as a blocking, and other will treat it as a designated port. So this is the blocking port, and then you have the designated port. So the summary of this explanation is that since you have such type of arrangement, so one of the interface is working as a blocking port, and suppose if your main interface is down, so still the traffic can go from this direction, because from blocking it will move to listening, then it will move to learning, and then it will move to forwarding. Okay, so it will take some 30 to 50 seconds to converge, and after that period of time the traffic will go from the blocking, because finally it will become the forwarding port. Okay, now here that's the problem, that we don't want to use STP, rather than we want to use rapid STP. We don't want to wait for this time to converge the network, and that's the solution is to use the rapid STP. So let's see that what are the things we have in the rapid STP. This is under 802.1W, or rapid spanning tree protocol. It's similar to STP, but there are dissimilarity as well. There are differences as well. We'll see that what are the differences we have. So BPDUs, here also you have bridge protocol data unit. These are the, you can think these are the control type of messages upon which the switches, they are building their STP, or they are building their RSTP. Here also they will select one root bridge as per the lowest bridge ID, that will be 32768. We'll see that in the next slide. Then the root and designated ports are elected and functional identical to STP. These are the similarities. What is not similar? You can see that here you have root port, alternate port, designated port, and backup port. In other hand, in STP, you have root port, designated port, and blocking port. So let me show you in the diagram. It's always easy to understand with respect to diagram. Here you can see that you have the lowest priority, so priority 100, who will become a root bridge. So this guy, and this is with respect to STP, and this is with respect to RSTP. So this guy is the root. Whatever going towards the root bridge is root port. Here you can see these are the root port, and then as per the high uh, priority, one will become block, one will be the designated port. If you have any issue in this direction, then it will move to the forwarding state and packet will flow like this. Correct? On other hand, you can see that in RSTP, here is the root bridge, for example. So these are the root port. We have a designated port, same like STP, but instead of blocking, here you can see that you have alternate port. Correct? And if you have two link, so one link is designated port, other one is the backup for the designated port. So instead of blocking, we have alternate port inside RSTP, and that is one of the reason for faster convergence, but there are other reasons as well. Here you can see that instead of blocking, listening, learning, and forwarding, we have discarding, learning, and forwarding phase. So we are not waiting for that particular amount of time, rather than we are moving to the forwarding state as soon as possible, as quickly as possible. Now, initially, a switchboard starts in a discarding state, obviously. Then he has to start his learning. Now, a discarding port will not forward frames or learn MAC addresses, as the name suggests. A discarding port will listen for BPDUs. Alternate and backup port will remain in the discarding state. So you have your alternate and the backup port. They are still listening, but they are not actively participating. So they are listening. Otherwise, if failure will happen, how they will start forwarding the frame. So they are not in the forwarding state, but they are still listening the BPDUs. Now RSTP does not need a listening state. Instead, if a port is elected as a root or designated port, it will transition from discarding to a learning. So here you can see that now if you have root selection, then in that case, the port will move from discarding to the learning state. Now what will happen in this case? A learning port will begin to add MAC address to the CAM table. However, a learning port cannot forward frames still. So here you can see that you have three state. In discarding, you are listening that. In learning, you are start learning the MAC address, but in discarding and in learning, still you are not forwarding the packet until unless you reach to the forwarding mode. Finally, when you reach to the forwarding state, then it will send and listen for BPDU, learn MAC address, and forward the frame. Root and designated port will eventually transition to a forwarding state. Okay, so once you have the selection of the selection of the ports, like root port, designated port, alternate port, etc., they will move from discarding learning to the forwarding state. Now the main question here, that why RSTP has faster convergence, and now you will see the core difference between STP and RSTP. Why? So BPDUs are generated by every switch and sent out as a hello interval. Switches no longer required artificial forward delay timer. Now what is happening in this case, that all the switches, they are generating their own bridge protocol data unit and they are forwarding to their peer switch. Okay. Now what is happening in STP? STP code is 802.1d. Now in STP, BPDUs are generated by the root bridge. Now, if switch receive a BPDU from the root bridge on its root port, it will propagate the BPDU to the downstream or its neighbor. This convergence process is slow and STP relies on forward delay timer to ensure a loop-free environment. So now you can understand that rather in RSTP, switches, they are generating the BPDU and sending to the neighbor. But in STP, that is 802.1d, you have one root port or you have one root bridge election. One switch will become the higher authority and then he will generate the BPDU, and all the downstream switches will listen as per their delay timer or as per their timer. So you can see here that the default nature of STP is slow rather compared to RSTP. Now in RSTP, switch will handshake directly with their neighbors, allowing the topology to be quickly sync. This allows port to rapidly transition from discarding to the forwarding state without delay. So you have one-to-one handshake, and then from discarding, it will quickly move to the forwarding state where they want to forward the packet. Now again, we have some port type in RSTP. We have edge port, and suppose if you know at this point of time about port fast. Port fast is one of the very popular term that whenever you are connecting the switch with the terminating device, say for example server, so you don't want to send the BPDU. So I don't want to send BPDU, or I don't want to send STP control packet to the device that is non-switch, which is not a switch. There is no meaning of that. So that's the reason this particular interface, we are making this interface as a port fast, means quickly it will go to the forwarding state. Likewise the edge. Now this edge port is working as a port fast, immediately it is going to the forwarding state. So there is no listening, learning, forwarding like STP, or there is no discarding, learning and forwarding like RSTP, but directly it will move to the forwarding state. Now second port type, we have the root. Root ports are connected with other switch and has the best path cost to the root bridge. Obviously we know that root port is there. That is, one side you have root port, other side you have designated port, so you can reach quickly to the root bridge. And then finally you have point-to-point port. What this point-to-point port is doing, that port that connect to other switch with the potential to become the designated port for a segment. So it can become DP. And now if you go and refer the actual diagram that we have here, so you will understand. So you have root port that is going towards the root bridge, and here you can see the adjacent to root port is the designated port. Designated port adjacent is root port, but here you can see that you have designated port and backup port as well. All right, finally we have some important notes here related to RSTP. So let me quickly cover this. Now if edge port receive a BPDU, it will lose its edge port and status and transition normal through the RSTP process. On Cisco switch, any port configured with port fast become the edge port. We know that. Say edge port, I already explained this, is port fast. Quickly move to the forwarding state. That's the summary for the edge port. Now the RSTP converge process is below. So let's quickly understand the convergence process of RSTP, why they are converging so fast, and we have discussed this in the earlier slide as well. So let me quickly revise this. Now switches exchange bridge protocol data unit to elect the root bridge. This is valid for all the spanning tree protocol. Now edge port immediately transition to forward state because they are nothing but the port fast. All potential root and point-to-point ports are start with the discarding state. So this is actually important. By default, the ports will start with a discarding state. Correct? Means they are actively listening the BPDU. They are not learning the MAC addresses. They are not forwarding the frame. They are learning. So you can think behind the scene. It's not learning actually. They are listening. So you can think this as a listening active listener. Then if a port receive a superior BPDU, it become to a root port and transition immediately to the forwarding state. So obviously once you learn the BPDUs, then you will move to the forwarding state. Superior means that suppose if you are getting one BPD, because in this case what is happening, all the switches, they are generating their own BPDs and they are exchanging it. So suppose this switch has low priority, say 32768, the default priority. Suppose this has priority 32769, he has 68. 69 is not a valid number, just for example. So obviously when he received the PPTU, he will understand, oh, I am getting this with the higher or the superior switch, and then this will become, so this particular point-to-point interface will become the forwarding state. Okay, for point-to-point port, each switch will exchange a handshake proposal to determine which port become the designated. Obviously, you can do the handshake and you have to define who is the designated. It's okay. Once the switch agrees, the designated port move immediately into the forwarding state. So here you can see the convergence is like little bit different than STP. So ports, they are starting with the discarding state and then they are moving to the forwarding state. At the moment you get some superior BPDU, it will become the root port. So again, remember, the- if he is the root bridge, that means that you are the root port and he is the DP. Okay, so if he is sending the BPDU, it will be superior BPDU, correct? And when he is sending the BPDU, he is not superior BPDU. So that's why it is telling that it will move to the forwarding state, because you have only one blocking type of a state, that is the discarding. So either you will be at the learning or you will be at the forwarding, and you will be at the discarding, but there are less chances that when you have the superior BPDU, you are in the discarding state. All right, so this is the summary for the RSTP convergence. Now every switch will perform this handshake process with each of the neighbors until all the switch will get sync. Complete convergence happen very quickly within the second. So all the switches, they are sending their BPDUs, and then switches, they are calculating on basis of BPDU and the superior BPDU. Now, whoever is sending the superior BPDU, he has become the root bridge and his interface will become the designated port. The adjacent port will become the root port because he has to reach to the superior bridge, and according to that all the switches will converge. Once they converge, once they sync, then RSTP will up and running to all the switches, and then it will take a few seconds, and that's why it's TCN in STP and RSTP both have different way. TCN is nothing but topology change notification. Now, what is happening in STP, say in case of when the switch move to forwarding state, or in a state of when they are going to blocking or down state, at that time they are generating the TCN, particularly in STP, that is 802.1d. Now that TCN bit will go to the root bridge, because we know that root bridge has to take a decision. Now what root bridge is doing now, that now if they are sending the BPDU, they are setting the TC bit, that is the topology change bit, and then they are forwarding this to all the downstream switches. So all the downstream switch will come to know that the port is going to the forwarding state, or switch interface is going to the forwarding state, or blocking or down state. Correct. Now again, this is little bit time consuming process, rather than in RSTP. What is happening, first of all, only non-edge port, when they are moving to forwarding state, so we know that this edge port are working as a port fast, or they are equivalent to port fast. Directly or quickly they are going to the forwarding state. So only non-edge port, when they are transitioning to forwarding state, they are generating the TCN. Now good thing about RSTP, that all the switches, that they can generate the BPDU and send the BPDU. So in this case, what is happen, that they are not waiting for the root bridge to understand or recognize that particular change, or that particular topology change notification, and then it will send to all the downstream switch, rather than the switch, whenever he got that change notification, he will update the other switch. So that's the reason this process is faster. So here you can see that any switch can generate the TC BPDU, allowing the topology to quickly converge via the handshakes. Now, a switch receiving a BPDU will flush all MAC addresses learned on designated port, except the port where they are receiving the TC, or topology change BPDU. So again, the core thing behind the scene is that all the switches in RSTP, they can generate and send the BPDU, and they can sync the RSTP database, or they can sync the RSTP states. correct? Rather than they will wait for some max age timer to be expire or some age timer to expire, or rather than they are waiting for some central authority, say for example the root bridge, to send the updates, to send the updated BPDU to all the downstream switch in the STP. All right. So here again you can see that we have some flavor of RSTP, and next section we are going to do the lab related to that. We'll learn on more on that. Now here you can see that not only the RSTP, their convergence is faster, but they are taking care of two failure. So either it's a direct or indirect failure. We know that the optimization of STP, if you read that STP, you'll find that you have certain mechanism that you can optimize the STP, like uplink fast, backbone fast, port fast is also one of the optimization technique. So port fast is already taken care inside the edge or the nature of STP or the edge port. Edge port is working as port fast. Then for direct and indirect failure, this is also taken care inside RSTP. So we don't need to optimize because these features are already included. So in case of any direct or indirect failure, the alternate ports or the backup ports, they will not wait. Rather than they will move to the forwarding state. Okay. Now we have two implementation of RSTP. One is rapid per VLAN RSTP, that is the Cisco proprietary. So because we are going to run the RSTP on a Cisco switch, so we will go and use this spanning tree mode rapid PVST. And the other one is the multiple spanning tree that we'll study in the upcoming sections. Okay, so we have our lab setup. Let me quickly show you this lab setup and what we are going to do here. So for example, this is the topology diagram that we have. What I can do in this that, so for example, I have switch 1 and switch 2 and switch 3. So here I'm going to run the RSTP in between switch number 1, 2 and 3 like this. At the moment, I'll not use all the interfaces, all the switches, but this will solve our purpose if we run the RSTP in between that, and then we'll go and run few of the verification commands. Okay, so let's stop here, and in the upcoming section, we have a lab related to rapid PVST or rapid STP. Now we have the lab section. So what we are going to do here, I'm going to run the RSTP in between switch number 1, 2 and 3. They are actually 101, 102 and 103. So here you can see in the diagram that we have the ports that is connected like this, say 1, 2 and 3. So here we'll run the STP and then we are going to verify that. Here are the interfaces E00 from switch 1 to 2 and then 1 to 3 and then 2 to 3. I'll figure out in the with help of show CDP neighbor, and then we'll run that. So what I'm going to do, first of all, I'll go and create a VLAN to all the switches. So let me quickly go and create the VLAN. So for example, VLAN 10, because we know that all the VLANs, they have their own STP instance. So I can go to this script and then I can select all. I can go to conf t and VLAN 10 and then we can exit. All right, so send this script to all the switches. All right, now once we have this, and we can go and check show VLAN. So we have VLAN 10. Now we can go and check show a spanning tree. And for spanning tree, we have a few very important and uh, interesting commands that we used to apply all the time, or we used to run all the time, like show spanning tree detail, show spanning tree summary. So here I can go and run the show spanning tree summary. Here you can see this summary of all these instances. Here you can see that blocking, listening, learning, forwarding, etc. Now we know that by default we are running STP, so that's why you're getting this result. We haven't enabled rapid PVST. We have to change the mode for that. We'll do that. Then you have the detail command. In detail command, you'll come to know most of the things like the topology change, notifications, the timers for STP, etc., and etc. So here you can see that we are dealing actually with switch number 1, 2, and 3. I don't want to add other switch and the interfaces, but we have so many interfaces that is coming here. So let me try to run few more commands, and then we have say interface. This is also very important command. So for example, interface 0/0 and enter. So now with this command, I can see that this particular interface is in forwarding state. The role is designated, and like that, I can go and check. So basically, say for example, I have 3 switch, and in this switch, I want to know that who is my root. So suppose I have switch 1, and then I have, say for example, switch 2 and switch 3. They are connected like this. So let's try to figure out first of all who is the root. Okay, so for that I can go again back to the show spanning tree detail, and here we'll see that who is the root for VLAN 10. I am not considering VLAN 0, so let's leave this VLAN 0. Everywhere we are seeing this VLAN 0. So let me quickly go and check that do I have VLAN 10 everywhere. So I can see I have VLAN 10 here, and then I should have VLAN here. So I have all the VLAN, although I haven't added any interface inside the VLAN 10. So what I will do that I'll move some interfaces inside VLAN 10. So let's do that. I'll do show CDP neighbor. Let's check that who is connected with switch number 2 and switch number 3. So here you can see these are the interfaces. I can go here, interface range E0/0 to 1, and this is switch port access VLAN 10. Likewise, I'll go and select the range that is from, here you can see 0/2 to 3, and this is also I'll make as switch port access VLAN 10. Okay, I'll go to switch number 2, and here also we'll run sociodp neighbor conft interface range E. Let's see. So we have 0/0 to until like that it is connected. So from 00 to 03, and finally we go to switch number 3, and we'll check that neighbors for 1 and 2. So these are the ports. So I can go here and do interface range 0/0 till 3, switch port access VLAN 10. All right, because we want to verify this only for VLAN 10. So show spanning tree VLAN 10 and then detail. So now here you can see this is telling you the information about VLAN 10. That's okay. And if I go inside VLAN 10 and if I go and check who is the root, so here you can see that the root port ID is this, the priority into the MAC address. So let's verify that this MAC address belongs to which particular switch. correct? So now if you go here and check, your MAC address is AABB C006500. Now if you see this particular output, and what is the priority? 32778. Why this is 778? Because 32768 is the default priority plus the VLAN ID. So that's why it is showing like this. So everywhere you will find that the priority is 32778. So whoever has the lowest MAC address, that switch will become the root, correct? Root bridge. All right, so let's continue this. All right, so we can verify like this, and uh, because we have two interfaces connected, so you are seeing interface E0/0 up to 0/3. Although if you go to any of the port and you'll see the detail, you can see clearly. For example, E0/2 for VLAN 10 is the designated forwarding, that is the DP. Whose cost, whose port priority, port identifier, you can see here, they have the priority of 32768 plus 10, that's the VLAN number, and this is the address. Now the designated bridge has priority this is the MAC address. Then again you can see the port priority and all other data. Now the question here is that in this scenario, who is the root and then who is the uh, non-root, or maybe who is the root and then what about the designated port and the root port and blocking, etc. Because we are running this spanning tree protocol at the moment. So for that you can go and check show a spanning tree, and then bridge means yourself. So we have two options here. One is the bridge option, that is my, and then what about the root? So I can go and check the bridge address and then the root address, and here you can see that bridge address for VLAN 10, we're focusing on VLAN 10, and root address for VLAN 10, both are same. So that means that this particular switch is the root. Now since this is the root, I want to know that what is the port status. So now if you go here and check, say for example VLAN 10, and say we have option for interfaces as well. Interface wise we can go and check, say E0/0, and then I can check the state as well and detail as well. So interface wise also you can filter. So for example 00 is the designated port. So if you go and refer the topology diagram, we'll find that we have different port from switch that is going to switch 1 to 2, say 00 and 01, and here also you have 00 and 0/1. So this is a DP. That means if you go and check here, this must be RP, correct? Again, whatever we have a study, we are following the same thing. So now if I go and copy this command here, we can see here this is a root forwarding. That's correct. So DP and RP, like that we can go and analyze. Now what we want to know here, I fully want to know the root address and the bridge address. So root address we know that will be 6500, and now again if you go and check the bridge address for this particular switch, what is the MAC address, because priority is the same. Likewise if you go and check the MAC address for this particular switch, you'll find this is 6700. So as per the lower MAC address, switch 1 is the winner. Now if you go and check this particular interface, that the interface between switch 2 and switch 3, here you will find this blocking. So spanning tree VLAN 10, say for example detail. Now for VLAN 10, you'll find that few of the ports, so this is root, it's okay, 00. You'll find blocking, and you'll find uh, ports here in switch 3. A few of the ports are in blocking stage. Okay, so this is related to STP. All these commands related to STP. So what are the big commands we have or important commands we have? Show spanning tree summary. It will give you the summary. So spanning tree, and for that particular VLAN, you can check the detail like this. Then you can check so spanning tree. So for example, sometimes we used to use filters as well. So for example, I can go and check include, and then um, we can filter certain things here. So for example, designated, or then I can add here designated, and say for example other also if I have. So everything is designated forwarding because of this is the route. So here you can see all the ports, they are coming like this. Yeah, so we have option, we can filter, we can add multiple filters as well. Here you can see that we have only 2 port address designated. All right, but what we have to do in this lab, that we have to go and run the RSTP. So I'll go to the switch and we have to change the mode. So spanning tree mode is, and if I type question mark here, you can see that you have mode MST, PVST, and rapid uh, PVST. Now, if you are changing the mode for rapid PVST, you should do this to all the switches, correct? So we'll go here and paste that command to all the switch. Then these switch will get converged. Once these switch will get converged, now we can go and check show a spanning tree, and you have the same options here, correct? So here you can see that for MST you have some other option, but show a spanning tree, and then we can go and check detail. Inside detail you can see that uh, VLAN 1, I don't want to check VLAN 1, but still VLAN 1 is executing RSTP compatible spanning tree protocol. You can check this. Better I can go and run the command show spanning tree VLAN 10 and then detail. So we can check only VLAN 10 commands. Now we will see that the port role will get changed. So DP will be DP. There is no problem on that in switch number 1. But if you go and check this in switch number 2 and 3, as per the rapid STP, the designation will get changed. So this is root, it's okay, designated forwarding, designated forwarding. Now here you can see this alternate blocking. So now you can see that the designations are getting changed. The role of the port is getting changed. So VLAN 10, so a spanning tree, VLAN 10 and detail. Now here also you can see this is the forwarding, alternate blocking, alternate blocking. Alright, so this is the way that we can go and run the RSTP, and then we can verify that. Alright, so we can verify like this. Again, if you want to check more options, you can go to show spanning tree VLAN 10. If you want to check root and then other options, here you can see that you have options related to priority, port, hello interval, details, cost, etc, etc. Then if you want to check some other stuffs, here you can see if I go to a spanning tree, again if I want to check the bridge and then the protocol, and if I press enter, so here you can see it is running in RSTP. Same thing that we have in STP, there is no much change, slight change in the configuration, but the verification options are the same for STP as for the RSTP as well. Hi there, thanks for your enrollment. We are in 1 minute ad break. In this break, I'm going to show you that I have so many courses uploaded over Udemy. And if you're going to enroll my courses, you will get 95% discount every month, 3 times. First week, mid of the month, and the last week of the month. I am sharing the coupons. If you go and use those coupons, then my courses related to CCNP, related to CCI, all those courses, you are going to get heavy discount up to 95%. You can see the prices are a little bit higher here, but if you go and apply the coupon, the prices will go rock bottom. So go use those coupons. Suppose if you don't have those coupons, then you can always ping me over YouTube. You can send me email. You can ask for those coupons. I will provide you that coupon. So get the coupon, get the discount. Some of my courses over Udemy, they are bestseller. Some of the courses are quite new, like SD-WAN automation, DNA automation, CCI data center 3.0. Those are the new uploads as well. So please go, continue your learning, take the coupon, enroll my courses, and study well. All the best. Next topic, we have multiple spanning tree, MST. Now, why we use MST, and it's very interesting that we should go and check the generation or the evolution of a spanning tree protocol. We have three different type of spanning tree protocol or STP. We have common spanning tree protocol where you have a single instance of STP for all the VLAN. Then to optimize that, we can use PVST or PVST plus, that is per VLAN spanning tree. Uh, Say when we have single instance for all the VLANs, so for example, I have VLAN 10, 20, 30, 40. At the moment you enable the STP, you'll find that that STP is running for all the instances of VLAN or all the VLANs. Rather than we can go and optimize this behavior with PVST, PVST plus, but still further we can go and enhance this process with help of MST. Because the problem with PVST or PVST plus is that you have to maintain a separate STP instance, and that will be overhead in terms of CPU and memory for the switch. So if you have, say for example, thousands of VLAN, so at that time it's actually very difficult for switch resources to manage that much amount of databases. Now what we can do in multiple spanning tree is that multiple VLAN instances can be mapped with one STP instance, or multiple VLANs can be mapped with one STP instance. By default, they will be mapped with MST0, but we can create from 0 to 15, means total 16 instances of MST is possible to create. Now here you can see that each MST instance, that is MSTI, builds their own RSTP topology database, including electing its own root bridge. Now the selection of root bridge and the various parameters are almost exact that what we are doing in the STP. Only the way that you are going to configure is different. So how we are going to configure the MST? First of all, obviously, we have to change the mode of a spanning tree to MST. Once we change the mode, then MST further separates the STP topology into regions, means we have to define the regions. All switches in region must be configured with identical MST parameters. So what are those parameters? We have 32-byte of configuration name, 16-bit of revision number, and then we should do VLAN to instance mapping. Now what all these things you can see here in the configuration, even in the lab also you can understand more about all these terms and terminologies. Now here you can see that important information that if two switches are configured with different MST parameter, they belong to different MST region. We can have up to 16 MST instance, 0 up to 15. So suppose if uh, I just started MST, so what will happen? Obviously, everything will be fault inside MST 0. So if you do not do any configuration, simply you enable the MST, they will fall under the MST0. We have this internal spanning tree is responsible for maintaining the topology for the entire region and all the MSTs. Only the IST can send and receive BPDU and encapsulate the MST information within the BPDU as an MST record or M record. The IST is always mapped to instance 0. So we have internal spanning tree as well, who is going to map or manage all the record inside the MST0. MST is compatible with other implementation of STP, and MST region is uh, obfuscated from non-MST switch, which will see the entire MST region at STP or RSTP switch. So it's not that, say, once we have multiple VLANs, so for example, I have VLAN 10 to 20, 21 to 30, I can map with MST instance 1, MST instance 2, etc. But still, they are compatible or backup compatible with other MST as well. Okay, and those information will come as a non-MST region. So it's something like you have MST, STP, and then you have non-MST STP. They are compatible. Alright, how we are going to configure? First of all, we need to change the mode, and then we have to go inside the spanning tree configuration. We can give the name revision, and then we have the instance to VLAN mapping, and that's it. Once we do the instance to VLAN mapping, we can go and check the pending. And earlier I told you that the way that we are configuring the STP, like how you're creating the primary or secondary or root or etc. Likewise, we have to do the things in MST as well. Okay, so the commands are very much similar. Instead of VLAN instance, they will be the group of VLANs or the instance mapping. Okay, so what we are doing inside MST is that we are mapping various VLAN to one instance. So instead of running the commands over VLAN, that is the default nature of traditional or the STP 802.1d, we are running the command with respect to instance. Now, where this instance is pointing to, it is pointing towards the group of VLAN, correct? So this is the way that we can utilize the resources efficiently. If we have the VLANs, we can group those VLANs, we can map with the various instances of MST, and then behind the scene MST will work with those groups, and the overall performance for the switch, say for example the resource utilization, the CPU capacity, memory, etc. will be efficiently utilized. Alright, so let's stop here, and in this section we'll perform the lab task. Let us perform the lab task related to MST. So first of all, what I will do that I'll go and create say VLAN 10 to 100, because we are going to map these VLANs with MST instances. So in all the switch, I'll go and do the same. So now we have VLAN 10 to 100, and we can go and verify this VLAN. I can see that you have these many VLANs that I can map inside the MST instance. So what will be the command number one? That I should go and change the spanning tree mode. So now the spanning tree mode is MST, and I should do this with all the three switches that we have. So let me go and go to the configuration mode and oops, conf t and copy paste this mode command. Again, I'll go to conf t and do the copy paste. Now what we can do, that we can go to the spanning tree and MST configuration mode. Once you are here, you can see that what options we have. You can go define the name, revision, instance. So we'll do that. First of all, I'll go and give the name. So for example, my MST, then the revision, for example, revision is 2. Then we have this instance. So instance and VLAN, so for example, instance 1, and then the VLAN range is from, say for example, 10 to 50. Then instance, sorry, then we have instance 2 VLAN 51 to 100 that we have created. We can go and check the configuration with show pending. So here you can see that you have a VLAN instance, and whatever VLAN that we haven't mapped here, you can see that they are mapped with MST0, correct? So now we have two instances like this. Great. Now once we have this, then I can exit and we can run the normal spanning tree command. So we have show spanning tree MST, and then we can check the configuration. We can go and check the detail. So instead of MST, you can think like you are running spanning tree VLAN. So instead of VLAN, you think like MST. That's the command. So we don't need to memorize the commands and all. So here you can see this in detail, and the port ID, priority, and everything is in detail. Now different type of VLANs actually is mapped with the MST instance, so that's why it is looking like this. Likewise, I can go and run this command to other switches as well. So I should go and change the mode to MST, then we should go to the configuration mode and run these commands. So let's do it, and we can verify with show pending, and then we should go here and do this here, show pending, and then we can exit and exit. Now we can go and check show spanning tree MST, and if you want to check the details, we have the detail option. If you want to check any of the interface, we can check that also. If I have my MST, that's the name of my MST. So MST instance list, say for example, if I give a word, and let's verify this. So what word I have here, you can see that show spanning tree MST. You can see the output in detail, and this is the name. And if I go here and check the output, say show spanning tree MS3, this is not supported here. So if I give, say for example, number like MST1, not like that, but we can go and give the instance list that we have. So what instance list we have created that we can actually verify in the configuration. So we have instance 1 and instance 2. When I'm giving 1, so MST1 is coming like this, and if I give 2, it is throwing error for 2. And if you go and check, so MST in detail, so we have MST0, we have MST0, we have MST1, and that's the reason. So it is showing only 2 instance. Rather, if I go here and check the instance in switch number 1, and if we go and check 2, we don't have information for 51 to 100, like MST2 is not created, but it's okay. This is the way that we can go and map the VLAN to the instance mapping, and then we can go and verify the commands as well. Now, one last thing, that if you want to change the priority, because switch 3 is having the lowest uh, it's the highest MAC address, so its priority is lowest in terms of selecting the root bridge. That's why here you can see that who is the bridge, who is the root. So root is the switch number 1 because its MAC address is the lowest. But if you want to change it, you can go and change spanning tree, MS tree, and then you can go and check the, let me quickly check the configuration. So we can do like this. If you want to change the priority, we have, say for example, VLAN 10. You can see the priority is there. Now this method is for the STP, but here we are focusing to MST, and then the instance, say for example, instance is 1, and here you have the priority. So this, we have two options, either we can use the priority command or the root command. I just wanted to make this switch as a root, and we can go and give him a root primary. And now if we go and verify the MST command, so here you will see that who is the bridge and who is the root. So this switch for MST1. So now his priority automatically get decremented, and now that switch 3 becomes the root. Now you can see their port status is changing. Initially it was forward blocking, but now everything will become forwarding, because now my switch number 3 is the root switch. Okay, and same rule is applied for STP as well. In STP you have to give the VLAN, in MST you have to give the instance ID. Alright, so let's stop here. Hi there, thanks for your enrollment. We are in 1-minute ad break. In this break, I'm going to show you that I have so many courses uploaded over Udemy. And if you're going to enroll my courses, you will get 95% discount. Every month, 3 times. First week, mid of the month, and the last week of the month. I am sharing the coupons. If you go and use those coupons, then my courses related to CCNP, related to CCI, all those courses, you are going to get heavy discount up to 95%. You can see the prices are a little bit higher here, but if you go and apply the coupon, the prices will go rock bottom. So go use those coupons. Suppose if you don't have those coupons, then you can always ping me over YouTube. You can send me email. You can ask for those coupons. I will provide you that coupon. So get the coupon, get the discount. Some of my courses over Udemy, they are bestseller. Some of the courses are quite new, like SD-WAN automation, DNA automation, CCI data center 3.0. Those are the new uploads as well. So please go, continue your learning, take the coupon, enroll my courses, and study well. All the best. Hi there, thanks for your enrollment. We are in 1-minute ad break. In this break, I'm going to show you that I have so many courses uploaded over Udemy. And if you're going to enroll my courses, you will get 95% discount. Every month, 3 times. First week, mid of the month, and the last week of the month. I am sharing the coupons. If you go and use those coupons, then my courses related to CCNP, related to CCI, all those courses, you are going to get heavy discount up to 95%. You can see the prices are a little bit higher here, but if you go and apply the coupon, the prices will go rock bottom. So go use those coupons. Suppose if you don't have those coupons, then you can always ping me over YouTube. You can send me email. You can ask for those coupons. I will provide you that coupon. So get the coupon, get the discount. Some of my courses over Udemy, they are bestseller. Some of the courses are quite new, like SD-WAN automation, DNA automation, CCI data center 3.0. Those are the new uploads as well. So please go continue your learning, take the coupon, enroll my courses, and study well. All the best. In section 1.2, we have to learn about OSPF version 2 and version 3. So let's learn about OSPF version 2 and version 3 in this section. Let's start with OSPF. Now, OSPF, that is Open Shortest Path First Protocol, is a link state protocol like ISIS. Now, what link state protocol is doing that instead of sending the entire topology table hop by hop, they are sending the state of a link to the neighbor device. Now, how this technology is working, and let me try to draw here. So generally, all the link state protocol, they are forming, first of all, the neighbor table. So they are sending the update to all the adjacent device or the neighbor. With help of neighbor table, they are forming the topology table. Sometimes we are referring this as a entire database as well. And finally, they ran the SPF algorithm here. From the topology table, they are going to form the best path, that is the routing table. So we have three different types of table: neighbor table or database table, topology table, and then finally the routing table. Now the mechanism behind this and the theory behind this we'll see in upcoming slides. So OSPF is entirely dependent upon areas. Generally, we are telling that we have one backbone area. So here you can see that you have area 0, and logically all the areas are connected with area 0. Now these areas are 32-bit. They can be a flat number, or you can define like in dotted representation 000 like this. Areas has continuous means area. You can see that you have area 0 and then area 1, 2, 3. So maybe you can think that can't I connect area 3 with area 5 or 4? Yes, we can do that connection, but you can see that area 4 is not directly connected with area 0. So somehow I have to create tunnel, or the area 3. Uh, I have to create area 3 as a tunnel, or we have to use some sort of virtual link. So area 4 can think that is directly connected with area 0. So such type of arrangement we need to do, and then the link state advertisement will flow from one place to other place. That's the LSA, correct? The OSPF send LSA when there is a change to one of its link, and will only send the changes in the update. LSAs are additionally refreshed by after every 30 minutes. So how we can summarize it, that OSPF is a link state protocol dependent upon area. They are sending their LSAs or their advertisement to all their neighbors, and with that they are forming the neighbor table, topology table, and finally the routing table. Apart from that, that OSPF traffic is multicast. They are using 224005 for all the routers and 224006 for the designated router. The theory behind this we can discuss in upcoming session. They are using the Dijkstra shortest path first algorithm to build the routing table from the topology table, and they are supporting the variable length subnet mask. So here you can see that first of all they form the neighbor table, then they form the database, then they do their algorithm, that's the SPF algorithm, Dijkstra's SPF algorithm. Finally, they will form the best path table, that is the routing table. OSPF supports IP routing. Their AD value is 110. Their cost, their metric is cost. They are going to form the neighbor table, topology table, and routing table. Uh, all the areas should be supposed to be connected with a backbone. That's the area 0. If we have non-backbone area connected with any other area, then you have to create tunnel or virtual link in between that. Now, suppose we have such type of topology here. You can see that I have area 0 connected with area 1 and area 2. So now what we are going to tell about these devices, these routers, router A and C, they are termed as a ABR, area border router. They are termed as a ABR, area border router, because they are in the border of different areas. Okay, and we'll see that according to that the routes are also going to get reflected. So when we are talking about the routes, you'll find that you have O routes and then OIA, that is OSPF intra area. So you have two type of route, OSPF intra area route, that is this. Then you have inter area, across the area, that is this, and we'll see that we have E1 and E2 routes as well, that is coming from the external as well. Now if you see this diagram, it's actually very simple, straightforward, that we have 2 or 3 routers in area, but assume that if you have 50 or 100 routers in area, and suppose if I have 200 routers and all the 200 routers are inside area 0. So at that time, what will happen? The computation, means to run that SPF algorithm, becomes CPU intensive, rather than if you have a small areas and then you have 50 device, 100 device and 50 device in those areas. So in that case, all the areas, they will run their independent SPF algorithm, and then they will send the update to the backbone. So in that case, the way that we are going to run the SPF algorithm, or in other words, the process, the CPU utilization, the memory, will be optimized and will be used betterly, because now you're running the SPF algorithm across small areas, and then those areas are going to send their LSAs to the core or to the other areas. Correct? So that's the thing, and that when we are that's why we don't have only area 0, rather than we have multiple logical areas, and then we are going to divide the devices or the routers inside the area. Then here you can see that, suppose in case that if you have device and that is not connected with the area 0, so in that case you have to create the virtual link, the device which is separating the area, they are termed as a ABR. Then you have internal router, then you have backbone router. Again, these are just the terminologies. All right, now here you can see that you may have chance that you are connected with non-OSPF protocol. So you are getting the route, say for example, from the EIGRP domain. So in that case, that router is termed as a ASBR, Autonomous System Border Router. So now here you can see that C and D, they are ABR, Area Border Router, but router G is ASBR, because now the routes is coming from the other routing domain to the OSPF. Okay, so uh, here you can see that if you have any other routing domain, that will term as a separate autonomous system, and then you have to do the redistribution. Obviously the router G will do the redistribution from EIGRP to OSPF when it is coming to OSPF, and OSPF to EIGRP when you are sending your update to the EIGRP domain. Now in that case, we have E1 and E2 type of area. Now what is E1 and E2? Here you can see by default it will be OSPF external area type 2, that is the E2. So include only the external cost to the destination network. External cost is the metric is cost advertised from outside the OSPF domain. This is the default type. Then you have E1 that will also have the metric value, that is the cost, but this will be additive, means it will add the cost per hop per router. So include both the external cost and the internal cost. So that's why you have the external cost plus the internal cost to reach uh, the ASBR to determine the total metric. But E2 having only the external cost that will be constant. So in summary, here you can see that you have internal routers, that all router interfaces belong to only one area. You have ABR, you have ASBR, you have backbone router that is inside area 0. Okay, so this is the baseline summary for the OSPF routing protocol. In the upcoming sessions, we will learn more about OSPF terminologies, and we have to perform the lab as well. So what type of LSAs we have in OSPF? OSPF has a long list of LSAs. We are going to discuss the top 5 at least because these we are going to use more and more in the course. So we have LSA here, you can see type 1 and type 2. Now these type 1 and type 2 LSAs are reside within the area. They are very much area specific LSA. Then we have type 3 and type 4 generated by ABR, area border router. They can flow from one area to other area. We'll see in the upcoming slide. And then we have type 5 LSA that is generated by autonomous system border router, means non-OSPF protocol. They are going to generate that. Now here you can see the detailed explanation of all the LSA. Type 1 is LSA and type 2 as well. They are within the area. The use of type 1 LSA is that they have the link, obviously the status and the cost of all those links, and they are generated by all the routers in a network. So you can think that type 1 as a default LSA generated by all the routers within that area. Then we have type 2 LSA generated by DR in the OSPF network or OSPF domain. Again, this is also specific to the area. When we have the broadcast type of network, obviously that time the DRBDR will come into the picture. Then we have the network summary LSA, that is type 3. What it is doing, that generated by ABR, and this can be used for inter-area communication. We'll see that all the places you have this inter-area link. So you have area 0 connected by different areas, and all these ABR shown in the diagram, they are going to generate type 3 LSA to do this inter area communication. Then we have ASVR summary. Now the next question here is, suppose from OSPF inter area you have to reach to non-OSPF domain. So for that reason we have autonomous system border router summary LSA, means somehow you need to reach, or somehow you have a route to reach to the non-OSPF protocol. Then we have external LSA type 5. Now this is generated by the ASBR, and this information will be flooded inside all the areas. So all the areas, if obviously you have the redistribution, all the areas should know how to reach to the autonomous system border router or the network behind the ASBR. We have type 6 as well, that is the multicast OSPF, type 7 as well, that is not so stubby area. And this type 7 is actually very important, and we'll discuss this later on. Now here in the diagram you can see that you have area 1, area 0, area 2. So belonging to area 1, area 2 and area 0, you have this router and network LSA, means type 1 and type 2 LSA will be generated in that. Then you can see that router C and D, they are ABR, so they are going to generate the type 3 and type 4, and then router G is belonging to ASBR, he is going to generate type 5 LSA. Okay, Great. Then how this OSPF is going to form the OSPF neighbor relationship? So if you go and connect two OSPF or two routers in between, so suppose for sake of simplicity, I have only two routers connected in a network. So in that case, what will happen? Suppose I have router 1 and router 2, and these two routers are connected, or they are inside area 0. So obviously these routers, because they are within the area, and suppose if it is a point-to-point network, then they will send and receive the router LSA, correct? So what will happen, that they are going to send their hello packet in the point-to-point network, or in the broadcast network. This hello timer is 10 second and dead timer is uh, 40 seconds, so it's 1 into 4. And in the broadcast network, actually, in the NBMA network, that will be 30 second, and then the dead timer will be 30 into 4, that is 120 second. So they will send and receive, they will exchange their hello packets, and if they are matching certain criteria while sending and receiving the hello packets, then they are going to form the neighbor relationship. So here you can see that what are the things inside the hello packet, what are the fields inside the hello packet. They contains area ID, area type, prefix, subnet mask, hello interval, dead interval, network type, and authentication. Basically it is termed as that they have 8 field inside hello packet, and you should match at least the area ID, the subnet mask, hello and dead interval, authentication, etc. So some fields are mandatory that should match in between two routers to form the neighbor relationship. Okay, so here you can see that a neighbor table is constructed from OSPF hello packet, which includes the following: the router ID, the current state, directly connected interfaces, and the IP address of the remote interface of each neighbor. We'll see that in the lab section, and we'll go and we'll run the command show IP OSPF neighbor, and then we can see the specific about the neighbors. Now the next topic here is that OSPF designated router and backup designated router. So what is happening and how they are going to form the DR BDR, or how they are doing the selection for the DR BDR. Let's discuss about that. So here you can see in the diagram, first of all, these devices, they should have their priorities. So let me show you what I try to tell here. I should have slide for that. Yeah. So here you can see that these devices, they have their unique identification. That's the router ID. All the routers in a network, they have the router ID. We can configure it manually, or suppose if device has the loopback interface, or they have the physical interfaces. First of all, they will check the loopback interface if you are not doing it manually. So that loopback interface will become the router ID, or the highest physical interface will become the router ID. So they should have the router ID. That will be by default if you are not doing it manually. Once they have router ID, then they are going to do the DR/BDR selection, and this selection will happen only in the broadcast network. So here you can see in the diagram that if we have router ABCD connected with a shared network or the broadcast network, so at that time they will go and select the DR and BDR. Okay. Now, what will be the selection criteria here? The DR/BDR selection are determined by the router's priority, which is configured per interface basis. The router with the highest priority becomes the DR, and the second highest will become the BDR, and the rest are DR to others, something like DR, BDR, others. Okay. Now, if there is a tie in the priority, whichever router has highest router ID, that will become the DR. Now we can go and set this priority like this also, like we can go to the interface and we can set IP OSPF priority, and then we can force to make certain device as a DR or BDR. Now, by default, the priority will be 1. So obviously the selection will happen with respect to router ID. So whoever having the highest router ID in the network, that will become DR, BDR, etc. like that, in that manner. Suppose if you don't want that certain routers or device will take part inside the DR, BDR selection, so you can go to the interface and you can set the priority as a 0. So if you set the priority as a 0, that device will not take part inside the DR, BDR. Okay. So what are the important things we have studied in this video? That type of LSA, then how they are going to form the OSPF neighbor relationship, what are the important fields you have inside the hello packet, all the devices they are sending the hello packets to their peer devices or the neighbor devices to form the neighbor relationship, then how they are going to form the DRBDR selection. Again, the router ID will be important factor here, and as per the router ID they are going to form the DRBDR, because by default we are not setting the priority. By default the priority will be 1, and according to the router ID they will select who is the DR, who is the BDR. Hi there, thanks for your enrollment. We are in 1 minute ad break. In this break I'm going to show you that I have so many courses uploaded over Udemy, and if you're going to enroll my courses, you will get 95% discount every month, 3 times: first week, mid of the month, and the last week of the month. I am sharing the coupons. If you go and use those coupons, then my courses related to CCNP, related to CCI, all those courses, you are going to get heavy discount up to 95%. You can see the prices are a little bit higher here, but if you go and apply the coupon, the prices will go rock bottom. So go use those coupons. Suppose if you don't have those coupons, then you can always ping me over YouTube. You can send me email. You can ask for those coupons. I will provide you that coupon. So get the coupon, get the discount. Some of my courses over Udemy, they are bestseller. Some of the courses are quite new, like SD-WAN automation, DNA automation, CCI data center 3.0. Those are the new uploads as well. So please go, continue your learning, take the coupon, enroll my courses, and study well. All the best. Let us learn more about OSPF neighbor state, and then I'm going to perform one small lab task where we'll understand more about the OSPF process, OSPF actually neighbor process, and even the baseline commands of OSPF as well. So now when the OSPF, the first stage is that they have to form the neighbor relationship. When they are forming the neighbor relationship, at that time they are exchanging, or they are going through a process, or they are going through multiple steps. So what are those states we have? Here you can see that they will start with a down, init, two-way, etc. So in down state indicates that no hellos has been exchanged, but the actual process will start from the init state. Init state, the devices, they will start sending their hello packets. We know that inside hello packet we have some important fields. Few of them are mandatory, like the area, like the authentication, uh, the network subnet, etc. So few of the fields are mandatory, that two sides or the neighbors, they should match those mandatory things. Then they will go to the two-way state. By the end of two-way state, uh, the devices, if they are in the broadcast network, they have to select the DR and the BDR. And by the end of two-way state, the devices, they are forming the neighbor relationship. Okay, then we have the external start and external exchange. Now external start and exchange is a state where the devices, they have to select that who is the master and who is the slave, so they can exchange their databases. So obviously the devices, they are sending their link state or LS information to each other. to build the database. Once they have the database as per the uh, master and slave entry, as per the master and slave rule, they have to exchange their ls type. Correct. So someone may sending say link state advertisement, someone may asking link state request, so lsa lsr, those things are going in depth when we are talking about the exchange state. Then we have loading, where all the devices they have to sync their database, and by the end of this loading state, the OSPF process, they are forming the topology table. Remember, we have three important table. We have neighbor table, so by the end of two-way state they will form the neighbor table. We have topology table, by the end of loading the devices will form the topology table. And finally, once they have the topology table, on top of that the devices will run the SPF algorithm, shortest path first algorithm, and then they have to form the routing table. We'll see that if we have the broadcast network, then they will have the rules like DR, BDR, and DR other. All right, so here you can see that suppose in broadcast network, if we have these rules, this DR other, they will go and stop at the level of two-way, because what is happening in that situation, in that case, is that we are giving the authority to DR and BDR to exchange all the LSs with all the other, rather than all the other DR others, they are exchanging their database packets. So that means they will stuck at the two-way state, means all the DR others, they will stuck at the two-way state, they will not have the full authority to exchange the databases. Correct? All right, so we have a small lab topology. In this first lab, just to start with, what we are going to do, that we will go and initiate the OSPF process. So let me show you this. Although we have this master lab topology, what we can do as per our requirement, will go and use it. So what does it mean? That we'll go and make these devices, say for example R1, R2, and switch 101 within area 0 at the moment. So they will be the part of area 0. And this switch that you are seeing here, switch 105, that I will make as a switch only. Later on we will make this as a L3, but at this point of time, I assume that I have R1, R2, and switch 101, and the IP that I am going to use, the IP will be, say, let me write here the IPs, and according to that I am going to configure the lab. So the IPs that I want to use is, say for example 10.1.1.1 and 10.1.1.2 as per the name of the devices, and here, so for example 10.1.1.101, they are inside the same broadcast network. So you can see that they will go and form the DR and BDR. Loopback addresses I will give like 111, and then this I can give 2222 as the name of the device, and this I will give as 101, 101, 101, 101. Okay, we are going to initiate the OSPF process inside area 0, and then we'll see that how they are going to exchange all those hello packets and the important ls type. All right, so let me go and log into the lab devices. All right, I logged in, and we know that we have other interfaces and links also connected that I don't want. So this is the topology that we have. What I can do here, that I will start with 101 E1/2. So let's do that. I can go to, first of all, let's see this neighbor, and I want to shut down few of the interfaces that I don't want to use. So for example, I want to use only interface 1/2, so 0001 and 1/2. So 0001. So I can do one thing. Interface range E0/2 to 3 shut down. Interface E1/0 shut down, because I want to use 1/2 only. So rest of the interfaces I'm making shut down. Like that, 1 also I want to make shut down. If I go and check show CDP neighbor, so I have 0001 and 12 that I want to use. Now next I will go to switch number 2. So switch 2 is not required in this particular lab, so leave it. Then I'll go to switch number 5, and we should check this E1/2 configuration as well. So I will go here and check E1/2, and what is configured here? Nothing is configured. If nothing is configured at this point of time, at least what we can do is we can make this interface as a switch port. Correct. So here you can see this capabilities R, S, and I, and that I don't want. I'll make this as a switch port. Then we'll go back to the switch number 5. Here you can see, and the interfaces we have is 0, 0, 1, 2, 3, and 10/0. So apart from that, what I want, that I want to make other interfaces as a shutdown, and we have so many interfaces. Here you can see, even we can leave it as well, just to check the configuration for any of the interfaces. Say so run interface E0/0 that is connected with router number 1, and then router 2. So these are the interfaces connected. I don't want to do anything. Rather, I will do one thing, that interface range E0/0 up to, for example, 4 maybe, and 3. I'll make this as a switch port and no shutdown. And then interface E10/0 that is connected with switch number 1. That if you see here, switch number 1, what interface we have here, let me scroll up, 10/0. Yeah, so I can go here, interface E10/0. I'll make this also as a switch port, no shutdown. Alright, so we are very much good with switch number 1 and switch number 2. Here again I can go to interface E1/2. I'll make this as a switch port, no shut. Alright, so let me quickly see here that what I exactly required. So E1/2 should not be switch port. It should be a routed port. So I'll do no switch port, and then I'll assign the IP address. So for example, 10.1.1.101, and then I'll create one loopback, say loopback 0, IP address 101 and 101.101. So what I have done here, we can check show IP interface brief. So I have interface E1/2 and one of the loopback interface where I have assigned the IP addresses. Okay. All right. Great. So now we can go to R1 and R2, and the interfaces you can see here. So I'll go to R1 first, and I can go to interface E0/0. I'll assign IP 10.1.1.1, and then I can do ping just to check that the switch far end switch is reachable or not. So it is reachable, then I'll go and create one loopback, say 0, and IP address I'll give 111 to that loopback. We'll go and check the show IP interface brief, so you can see that we have the IP configured here. Now let's go to R2, and inside R2 we have interface E0/0. I can go and give the IP like this, and then I'll create one loopback 0 where I can give IP related to as per the diagram or as per our schema 22222, and then let me try to ping. First of all, within the same network, obviously everything is inside the same network for this example. So what I'm doing, that I'm pinging to all the devices from R2. So now we have the baseline IP address connectivity connected. The thing here is that we are going to enable the OSPF to all these devices, and we are assuming that all these devices are inside area 0, correct? So let's do this, and let me go back to the lab. Yep. So before doing that, at least one of the device I want to enable the debug. So I want to enable the debug OSPF packets and events, debug IP OSPF packets, and then I want to enable the events as well. Okay, let's do this OSPF configuration. So we can go to router OSPF, and then you have to define the process ID, say 1 I'm giving at this point of time. Then I should go and advertise the network. So network is, I have two network, one is 10.1.1.0. I can go and give the wildcard bit inside area 0. So this is the format that we can go and enable the OSPF. And at the moment I enable that, you can see that we have event because we have enabled the debug as well. You can see that this router using this multicast address, and the router ID is get selected as 11111. We have discussed this earlier. If I go and check show IP OSPF, you can see the red router ID is 11111, and we have the other information as well. Okay, so we have the OSPF configuration, and periodically he is sending the hello packet. We can go and check the configuration for that, what we have done. So we have enabled the OSPF process, and then we have advertised the network, correct? So likewise, I can go here and initiate the OSPF process here as well. Then I can go and I can assign the router ID via the CLI command as well, means manually as well. But if you do not do this, automatically they will take that loopback, highest loopback address as a router ID. So then I have network 10.1.1.0.0.0.0.255 area 0, and then I have network 2222, say 0.0.0 area 0. Alright, and let me see that what configuration I have done here. Now they try to exchange this neighbor relationship. From there they will go and form the topology table, and finally they will go and form the routing table as well. Okay, so let me quickly see that what command I have given here for the network, because we have used /32, that's why I have given 0.0.0.0.0. Now somewhere you will find that you are moving to loading to full state, and here if we can see that information in the log message, So we have enabled the debug and OSPF authentication is 0. We haven't put any authentication, so it is telling that OSPF authentication is 0. And here you can see that we have this loading to full message. If you go and check show IP OSPF neighbor, then you can see that you have DR BDR selection already happened. For router 1, he is telling that router 2 is BDR. Now if you go to router 2 and if you check show IP OSPF neighbor, you can see that he will tell who is the DR. So for router 2, this 11111 is the DR, what is the interface, what is the IP address that we have discussed earlier. Now I'll go to switch number 1, and here also I'll go and do this router OSPF say 1, and then I will put the network, for example the loopback address that we have 101.101.101.0.0.0.0 area 0, and then I'll put the network that we want to form the OSPF relationship. So we have a network and with the wildcard bit 0000 to 55. All right, and within area 0. At the moment I'll do this, I can go and check show IP OSPF neighbor. Now you can see that he is seeing that who is the DR and who is the BDR, correct? The third device. Now if you go here and check the OSPF neighbor, you can see clearly that DR other. So now this IP is DR other. We haven't assigned the router ID manually, but here you can see that they can detect it. Means the router process can go and assign what will be the router IP or router ID for these devices. We can go and check like this, show IP OSPF, and you can see the ID. Now if you want to filter and use that, I try to do with this command, simply you can go and check the ID. That will tell you who is the router ID. Alright, so this is the way that they are going to form the DR and BDR. And if I have one more device in the DR other, then you could find that the process will stuck as two-way state. Okay, so what I'm telling here is that if I am here and if I have one more device connected to this guy here, and that is also working as a DR other, then these two devices, they will form the, they will stuck as a two-way state. They will not exchange the entire topology and database tables, etc. All right, so let's stop here. In this session, I'm going to cover OSPF network type, metric, and passive interface. And next section, we'll do the lab related to this. Now, if you go and check the syllabus, so let me quickly show you the syllabus. In this syllabus, you'll find that in 3.2, you have to learn about OSPF and you have to compare with EIGRP. So for that, what I'm going to do, that I'm going to cover EIGRP in different series of videos. So once we know OSPF, once we know EIGRP, it's easy to compare. Then in 3.2b, you can see that we have to learn, understand more about OSPF. And that's the thing we are doing at this point of time. So let's quickly understand the network type, OSPF metric, and the usefulness of passive interface. Now, OSPF is supporting a wide variety of network type. Here you can see that in OSPF, you have these many network type support. Now, how to memorize this, because you can see it's a big number, this network type. So you can think like this, that you have point to point and you have, see here, so point to point, and then you have point to point, point to multi-point, broadcast and non-broadcast, like you can think. So you have network type broadcast, and then you have network type non-broadcast, and then again if we add with point to point and point to multi-point. So now point to point, obviously we know that point to point is just point to point network. Two devices are connecting with each other. It's a point to point network. Then what about point to multi-point? So here you can see that point to multi-point non-broadcast. So you can think that you have point to multi-point broadcast and non-broadcast. Okay, so that means you have 1, then 2 and 3. Apart from that, you have network type broadcast. So you have network type broadcast and you have network type non-broadcast. That means you have total 5 different type of network support. Now again, if you go and check the nature of the broadcast and non-broadcast, so if it is a broadcast, that means the DR/BDR selection will happen and the neighbor will form automatically. Means you don't have to write the manual command to form the neighbor relationship. Correct? But if it is a non-broadcast, and suppose if DR/BDR is forming, you can see that the hello is unicast multicast. When you're seeing unicast means you have to go and use the neighbor command. So you have to manually form the neighbor. Correct? So once we know about the broadcast and non-broadcast, and again you can see the timer as well. For broadcast network is 10 and 40, and for non-broadcast is 30 and 120 seconds. Correct? Now same concept we can use here. So here you can see that point to multi-point. You can think this is a point to multi-point broadcast. So that's why it's a multicast. Hello. They will not form the DR/BDR because again it's point to point, and you have so many points to point means point to multi-point. You can think like this. So whenever you have point to point network, you are not going to form the DR/BDR because just two devices. Why you will form DR/BDR? Then I get point to multi-point non-broadcast. Now this is non-broadcast, so that's why you have to go and use the neighbor command to form the OSPF neighbor relationship. That's the whole summary we have for the OSPF network type. So let me go back to the theory. Now here you can see that it's a broadcast. So it will do DR/BDR selection, then it is using these multicast addresses. Because this is the broadcast, they will not form the neighborship manually. Automatically they will form. Point to point, no need to define the neighbors because you have only two ends. They will form the neighbor relationship. Their timers will be 10 and 40 seconds. They are going to use the multicast address. But again, point to multi-point as well. Everything that is valid here for point to point, it will be valid for point to multi-point as well. Okay. Now, then we have non-broadcast. Whenever we are talking about non-broadcast, then you have to go and form the neighbor relationship manually. Now OSPF will elect DR and BDR, but neighbor relationship will be manual. And that's why we have this summary. This summary, it's easy to memorize. Even no need to recall, but just will make a point that okay, you have point to point, point to multi-point, point to multi-point, non-broadcast, point to multi-point broadcast, and then you have broadcast and non-broadcast network. How we are going to do the configuration part is actually very easy. Only one command is there to define the network. You have to go to the interface. Suppose you are over this serial interface, you go to the interface and use this command IP OSPF network. Suppose if you go and type question mark, then you'll get all the options. So is it a broadcast? Is it a non-broadcast? It's a point to point, point to a multi-point, etc. Each and all these options you will get. And if it is using unicast method, means if it is a non-broadcast, then you have to go and define the neighbor. Otherwise, rest of the configurations are standard OSPF configuration. So for example, NBMA, non-broadcast multi-access. So here we are going and defining the network type is a point to multi-point, and if it is a non-broadcast, then you have to go and define the neighbor, right? So just refer this summary and things will become easier. Now OSPF is using cost as a metric. Here you can see the speed and the cost. So for example, for fast Ethernet and above, your cost will be 1, and then you can see for token ring for Ethernet, for token ring 4 Mbps, you can see the cost. Now the lower is better. So if lowest cost is there, that will be the preferred path in the route selection. How we are going to do the basic OSPF configuration, although we have done one lab. So there you have seen that you can go and initiate the OSPF process. You can define the router ID, otherwise it will take the highest loopback or highest physical interface if it is not configured. Then you can define the area, and that's it. So this is the baseline configuration. Now here interesting thing is that we are defining the wildcard bit. And now it is recommended that if you know the exact subnet, so according to that you can use the exact wildcard as well. So suppose if I am using point-to-point network, so I can use, say for example, 172.168.1.0. So here it's 17. So 172.171.0, and then I can use wildcard 0.0.0.3. So like that we can go and use the wildcard wisely. What will happen if we go and initiate the OSPF process, and once we start advertising the network, or once we put this network command, then they will send the hello packet, the neighbor relationship will start working. We know that the steps down, init, two-way, X start, exchange, loading to full. First they will form the neighbor table, then topology table, and finally they will run the SPF algorithm and we'll get the final OSPF routing table. Correct. Now the final thing here in this recording, as per the theory, the passive interface, the concept of passive interface. Now suppose if you don't want to form OSPF relationship, then you can go and make any of these interface as a passive interface. So suppose if I make this interface as a passive, then you can see that the passive means the command prevents update from being sent out or received from this interface. So if I go here in this example, it is showing this interface. So if you go and make this particular interface as a passive, or any interface as a passive, they will not participate in OSPF neighbor relationship. Means they will not send or receive the updates, and that's the usefulness of passive interface. But generally, how we are using this command is we will do this thing: no passive interface E0. Here you can see first of all we'll make all the interface as a passive. So the command one is passive interface default. Suppose if you have 10 interface, that means all the 10 interface you're not sending and receiving the updates, and then you will go and add the interfaces one by one where you want to send or receive the updates. Okay, we have one important note here that the passive interface command will prevent OSPF and EIGRP from forming neighbor relationship out of that interface. No routing updates are passed in either direction. So this passive interface is true not only for OSPF, but this is true for EIGRP as well. So we are going to stop here, and in next section, I will show you a few of the things that we have a study here, like network type, how you can go and change the network type and you can enable the passive interface. Hi there, thanks for your enrollment. We are in 1 minute ad break. In this break, I'm going to show you that I have so many courses uploaded over Udemy, and if you're going to enroll my courses, you will get 95% discount every month, 3 times. First week, mid of the month, and the last week of the month. I am sharing the coupons. If you go and use those coupons, then my courses related to CCNP, related to CCI, all those courses, you are going to get heavy discount up to 95%. You can see the prices are a little bit higher here, but if you go and apply the coupon, the prices will go rock bottom. So go use those coupons. Suppose if you don't have those coupons, then you can always ping me over YouTube. You can send me email. You can ask for those coupons. I will provide you that coupon. So get the coupon, get the discount. Some of my courses over Udemy, they are bestseller. Some of the courses are quite new, like SD-WAN automation, DNA automation, CCI data center 3.0. Those are the new uploads as well. So please go continue your learning, take the coupon, enroll my courses, and study well. All the best. Let us do the lab. Here you can see the topology. Uh, we have router 1, router 3, and switch 101. I'm using in between switch 105 as a L2 switch. So that means I have area 0. So this big blue circle is area 0, and the network is 10.1.1.0/24. Then I have switch 101 and 102 connected. That is inside area 2020, and the network is 10.1.102.0. So 101 is dot 1 and 102 is dot 2. I have already assigned the IP address. So what we'll do, we'll go and enable the OSPF process. Then we'll go and check the default network type, and then I will make any of the interface as passive interface inside area 0, and then again we'll verify the OSPF neighbor relationship. So let's do this. I can go to router OSPF 1, and even if we are here, we have option that we can run this script as well. So if you're doing the configuration over empty putty, you have this option for a script, say conft router OSPF1, and then you can advertise the network as well. I can select the devices and then I can send the script. Now once OSPF is configured, then I should go and assign the, or I should advertise the network, or should I can use the network command. So what you can do here, you can go and check the IP route, your connected interface, and in the network command, actually, you can go and use it with wildcard bit, and we should check this 10.1.1.0 is part of area 0. So we know as per our topology this is correct. Then we have one loopback here that will be depend that in which area you want to put. This also I'll put inside area 0. And then I have one more network that is this guy here connected with area 20, area 20. So these are my network command. Likewise, I can go to switch number 2 and I can go and check the connected routes. I can use my network command. First of all, I'll advertise my loopback inside area 20. And then I have my network that is connected, that is inside area 20, because the bottom switch is actually everything is inside area 20. So that's why area 20, area 20. All right. So at the moment we run this command, you'll find that both the switches, they are now interfaces are part of area 20, and they will run the OSPF, and here you can see that the OSPF loading to full means all the states are completed. So I can go and check show IP OSPF neighbor. You can see full BDR and the interface as well. Then we can go and check show IP OSPF. Actually show IP route OSPF. So here you can see that you have the metric value and you have the AD value. AD is 110 and the metric is 10 plus 1. So that's why it is 11. We know that for Ethernet interface that is 10 and then 1 is for loopback. So that's why it is showing like this. Alright, here you can see the Ethernet. So for that we have 10 and then generally 1 it is using for loopback. Alright, next thing that I want to check here is that is show IP OSPF interface, and that is E0/0. Now here you can see that interface where the network type is broadcast. So what I can do that the switch is connected over E00. I can go to the interface E00 and I can make that IP OSPF network as point to point. Now here you can see that you have broadcast, non-broadcast, point to, multi-point, point to point. And if you go to point to multi-point and type question mark, you have point to multi-point. By default, it will be broadcast, and then you have the non-broadcast like that. So I'm interested to make this as point to point, and both side I should do like this. So other side also I should go, and I should go here to E0/0 network point to point. Now you can see that again OSPF process is running. It is going from full to down, and the SPF algorithm is running one more time. And then we have the new tree, SPF tree, and from there we have new routing update or routing table. Show IP OSPF and the interface is E0/0. You can see this network is now point to point. You can see this cost as well. There is other information as well related to timers, non-stop forwarding, etc. All right. So we have done this task with these two switches here. Likewise, I will go and initiate the OSPF process, and I will advertise the network for R1, R2, and only R1 and R2. We don't have any R3. All right. So let me quickly check here in switch 101 what is the complete OSPF configuration that we have done. So these three network, one network is belonging to the network that we have connected with R1 and R2, that is nothing but the area 0. And then these guys have one loopback address 111 inside area 0. And likewise, I'll go here and then I will use 222 area 0 and then this. Now if I go ahead and check show IP OSPF network, here we have three devices who is forming the OSPF relation. If I go and check show IP OSPF interface, I want to check the interface E0/0. So here I can see that again the network type is broadcast. Now in our topology, either I can use network type as a point to point or broadcast, but we have seen that chart that as per the topology, suppose if you are working or dealing with frame relay, then you can use NBMA and then you have the mode for NBMA, correct? I don't want to make this as a non-broadcast. If you make this non-broadcast, so suppose if I go to R1 and R2, and I should know what is my neighbor, show IP OSPF neighbor, and if I go to interface E0/0 and if I make this IP OSPF network is non-broadcast, then I need to add the neighbor command manually. So now if you check your neighbor, you can see it's a down, because in this case you have to use this neighbor command. So you have to go to router OSPF1 and use the neighbor command. Who is your neighbor? So this guy is your neighbor. Then use the neighbor command. This guy is your neighbor. So manually we are adding the neighbor now, and here also it is detached. So these are my neighbors. I'll go to interface E0/0. IP OSPF network is non-broadcast. Then router OSPF1. We'll go and add the neighbor, this, and again I'll go and add one other neighbor. Then we can go and check show IP OSPF neighbor. Still this is down. Show IP OSPF interface and then E0/0. So now it become non-broadcast, but we are seeing here that the network is down because we are using the wrong network type here. If we have the NBMA type of, or if we have a non-broadcast type of network, then we should go and use here. Again, you can see this hello and dead timer is changing. Okay, so what I'll do here that I'll go and make this interfaces again backup. Interface is 0/0 and IP OSPF network is, say for example, broadcast. So one side is broadcast and other side is non-broadcast at this point of time. And now you can see it is forming the relationship with the switch 101. So if I go and check do show IP OSPF number, you can see it is forming this. Likewise, I'll go here and again interface is 0/0. IP OSPF network is broadcast, and then we can go and check show IP OSPF neighbor. Alright, so now we have to test the final piece, that is the passive interface. So suppose if I go and make one of the interface over R1 as a passive, so let's do that. I can go to router OSPF1. You can see that we have this command passive interface default, and then you can go and make no passive interface. So once you do this command, all the interfaces become passive, means your neighbor is down. So here you have to use no passive interface, and that is the E0/0. E0/0 is the interface. I want to make no passive interface. And again, if I go and check the neighbor, so here you can see this is up. So that was the lab related to whatever we have studied in the previous recording. You can refer this particular lab. Next, we have OSPF authentication and virtual link. So let's start with OSPF authentication. Now, actually, it's very easy to configure and it's different than RIP and EIGRP. What we can do, first of all, we can go to the area. So here you can see I'm over OSPF, I'm inside area, I am putting area 0 authentication. Then I can go to the interface level and then I can go and give the authentication key. So we have two things. We have the plain text or clear text, and then we have MD5. Now same way we can go and configure the MD5 as well. So again you have to go to area 0. Here you can see that I'm over area 0 here and the authentication message digest. Then I will go to the interface and then I can assign the message digest key. So it's very easy and straightforward. I'm going to show you in the lab section about the message digest key, this authentication. So more we can discuss in the lab. Now next thing here is, what about virtual link? Virtual link is again one of the use case we have in OSPF, that for example, due to any reason, the customer network, they are not able to directly connect with area 0. We know that all the areas should be connected with area 0. So suppose you have area 1, 2 and 3. For example, later due to some reason you are connecting area 4 with area 3, not with area 0. So in that case, we can create the tunnel in between area 0 and area 4. So the router inside area 4, they will think that I am part of area 0 or I am directly connected with area 0. And that's the concept of virtual link. Again, you will see the configuration here. The configuration, you'll find it's a very much like we are creating that tunnel. So router, the area 1 is working as a transit, and then I have tunnel in between, say for example, area 0 and area other area. So let me go back here. So here you can see this is a classical example that you have area 0, area 1 and area 2, and then you are creating the virtual link in between that. Okay, now there are possibility that you may have area 0 and in between you have area 1, and that's again the possibility is less, but still you can create the virtual link in between that. Now once we create the virtual link, then over the area 0 we have put the message digest. So same key we can put over virtual link as well. Okay, so we have seen all these steps, and let's perform the same task in the lab setup. So we'll understand more about the authentication and the virtual link. Let us perform the lab related to authentication and virtual link. I have done the change in my setup here. You can see that now we have R1, R2, and that's R2, but switch 105, then switch 101, and then switch 102. So R1 switch, and then again switch, and then the switch 102 in the bottom. Subsequent network IP addresses I have changed. So we have network 10.1.1, 10.1.2, 10.1.3.0, and then we have respective area like area 0, area 1, and area 2. Now in lab number 1, we'll go and um, create or run the OSPF in between area 0, and then we'll do the MD5 authentication. In the same lab later on, we have to create the virtual link and we have to make area 1 as a transit. All right. So let me show you this IP addresses assignment here. You can see that we have created and assigned the IP addresses only so far as per the diagram. So oops, these are the IP addresses assignment related to R1, R2, related to R1 and all the switch. So now let's start with area 0, that is R1 and switch 105. I'll go here and enable router OSPF1. Then I have network, say for example 11111, and then I'll put this inside area 0. So let me do that. Then I have network 10.1.1.0. This also I'll put inside area 0. Alright, now we'll go to the switch, that is switch 105, and we can go and check the network. First of all, we'll go and initiate the OSPF process. Then we have one network that is 10.1.1.0, but we have 105.105 network as well. So let me quickly do that, and 00000 area 0, for example. Then we have the rest of network. So now you can see I have enabled this, or I ran this command, but still I can't see that OSPF is coming up and running. So I should go and check the IP over E00, and we should have at least IP reachability. So E00 here, it is correct. If I go and check the interface configuration for this switch, so let me try to check 0/0. Wow. So we have this command configured and protocol is up. So if I do the ping, so let me do the ping from here for 10.1.1.1. That's the router IP. And I can see that ping is working. If we could go and check show IP OSPF neighbor, show run section OSPF. So here you can see that I have this network inside area 0, and then I have my network, that's the loopback, but still I can see that they are not forming the neighbor relationship. So now what I'll do, I'll go here and make this network as a 10.1.1.0 area 0, and then I'll remove this network statement. You can see that the problem here we have. Then again I'll go back and delete this and add this. So let me try to do both at a time. In router number 1, okay, and let's try to check show IP OSPF neighbor. Now they are in two-way dweller state. They're stuck in dweller state. Alright, and if I go here and check in this, because we haven't removed OSPF from here, show IP OSPF neighbor. Okay, so the reason maybe now it is up. Maybe the network type that we haven't changed, but now it is showing it is up and running, so that's okay. Now we have the OSPF relationship over area 0. What I want to do now, that I want to run the authentication. So I can go to router OSPF 1 and then area 0 authentication. Here you can see that you can do plain text if you want. You can leave with this authentication, or if you want to do the MD5, that is the more secure, then you can go and use this. Now at the moment I have done this, you can see that the neighbor is up, but we are getting one problem here, that authentication key, you don't have any valid key. So now what I'll do, I'll go to 00 and then IP OSPF authentication. You can see that you have authentication and message digest option. So I can go and put the key as a CCNP. You can see here that you can go to authentication and key, and then you can see here that you have option say unencrypted. This is not that I'm looking for, so I can go and give the message digest, but I want to put the key as well. So let's see, IP OSPF authentication, and we can give the authentication if it is a plain text, an authentication key. And suppose if I'm using authentication, then I have this option for message digest. Actually, that is quite a confusing option that Cisco is giving to you. So, because obviously natural thing is that we'll go and check IP/OSP of authentication, and then whatever authentication will be there. But in case of message digest, you should go and check IP/OSPF, and then you have this option of message digest key if you want to put your key. So I'll put key as the CNP, but let's see, yeah, MD5, and then so this is the long command that we need to put here. Now if we go and check show IP OSPF neighbor, we can see that neighbor is down because of mismatch of the, or we don't have the key configured to the other side. So here also we can go to router OSPF1 area 0 and then the authentication message digest, and then we'll go to interface E0/0 IP OSPF message digest key. Now we are getting this error MD5 CCNP. So now you can see that the neighbor is coming back up. So this is the way that we can go and do the authentication inside area 0. Now what I want to do here, that I should go to the I should first of all do the OSPF rest of the configuration, and then we'll create the virtual link. So let me do that. R1 is okay. In R2, let me check show IP route and what network that we have configured so far. So we have router OSPF1. We should have one more network, that is 10 dot let's see the network. That's 10.1.2.0. So 10.1.2.0 0000255, and that is inside area 1. Correct. So this network is in area 1. Now we have switch number 101. So let's do the configuration for switch number 101. And what network we have? We have network 10.1.3.0, that is in area number 2. Then we have network say 101, 101, 101, 101. So for example, I'll put this in area 1, and then finally I have 10.1.2.0, that is inside area number 1. Alright, so we are very much done with this OSPF configuration. Finally, we have switch number 102, where we have 10.13.0 network. So I'll go here as well and should enable OSPF, and then we have network. Say for example, first of all I'll advertise the loopback, and this is inside area 2. And finally we have network 10.1.3.0, that is again inside area number 2. Now here you will see that after running all these commands, we go and check show IP OSPF neighbor. So he has neighbor that is 102 and 105. Now if you go here and check to the switch 105, you will find show IP OSPF neighbor. So he should also have two neighbor, but if you go and check show IP route for OSPF, you'll find that he is not getting 102 because it is never getting tunneled or passed through the area 1. So in this case, we should go and create the virtual link. Okay, so let's create the virtual. So I'll go and create the virtual link here inside area number 1. So first of all, 105 and then 102. So already we are here, and router OSPF1 area 1, and then the virtual link. What is the ID? So we know that the neighbor ID is this. You can see here that we have option for message digest key as well, that I'll put later on. But that's it. Area, virtual link, and then the peer device router ID. Now I'll go to 101. I'll go here and router OSPF1 area 1 virtual link is what's the router ID you're looking for to make the tunnel. That's sorry, not this one. This is 105. Okay, so I'll go and remove this, and that's it. So once you do this, then if you go here and check the OSPF, you'll find that you will start getting the routes. Now what is happening here in this case, that since you don't have key configured, so inside area 0 we have the key configured. You should go here and give the key so it will work properly. Go here, and here also we'll go and we should give the key, say CCNP, and now you will see that they will start getting the routes. So if I go here and check show IP OSPF neighbor, now show IP route OSPF, you should get 102 102 102. That will be the final valid verification for this. So after running this command, I can't see that anything is happening. And let me go and check here as well. You can see this configuration is 100% correct. You're creating virtual link with this, and in router 1 also the configuration key, everything is correct, but it's still they are not forming this. So what we can do here, that we can go to router OSPF one more time. Router OSPF1 area 1, say for example the authentication is message digest. This belongs to area 1, and here also we have area 1 as well. Let's see the final configuration. SPF. Now invalid key for 10/0, that we can verify. So what is happening actually here, that if you go and check the configuration, you'll find that once you are putting the key here over the virtual link, now this belongs to inside area 1. These are the interfaces where you have to put the authentication key. So for example, as a MD5. But when we are creating the virtual link, actually, in that case, that is going to propagate area 0 only. So it's not required to put the key there. Okay. But just for the security purpose, I'll go and put the key over 10/0 and E1/2 as well. So E say 10/0 and IP OSPF, or maybe IP, yeah, OSPF message digest key 1 MD5 CCNP, correct? And then finally, I can go here and interface E2/1/2. Wow. So this much configuration we have done. And now if you go and check show IP OSPF neighbor, first of all, we should have the neighbor. And if I go to R1 and if I go and check show IP route, so here you can see that it is getting the route as a uh, O routes, as it is directly connected with area 0, and we don't need to put actually authentication over the area 1 interfaces that I have done, but for sake of security we want to put the authentication key at all the places, so you can go and put the authentication keys at all these places. All right, so this was the authentication and the. Hi there, thanks for your enrollment. We are in 1 minute ad break. In this break, I'm going to show you that I have so many courses uploaded over Udemy. And if you're going to enroll my courses, you will get 95% discount every month, 3 times. First week, mid of the month, and the last week of the month. I am sharing the coupons. If you go and use those coupons, then my courses related to CCNP, related to CCI, all those courses, you are going to get heavy discount up to 95%. You can see the prices are a little bit higher here, but if you go and apply the coupon, the prices will go rock bottom. So go use those coupons. Suppose if you don't have those coupons, then you can always ping me over YouTube. You can send me email. You can ask for those coupons. I will provide you that coupon. So get the coupon, get the discount. Some of my courses over Udemy, they are bestseller. Some of the courses are quite new, like SD-WAN automation, DNA automation, CCI data center 3.0. Those are the new uploads as well. So please go, continue your learning, take the coupon, enroll my courses, and study well. All the best. Next important section, we have OSPF summarization, different type of areas, and the default route concept. So let's start and understand the summarization. Now clearly you can see in the diagram that you have area 0 separated by area 1 and area 2. And for example, if you're getting routes, say 10, 1, 0, 0, 1, 1, 1, 2, 3, up to 7. And other side, you can see that is 8, 9, up to 15. Now, we are sending all these routes to the core router. Here you can see all the individual route. And hence, the database or the topology table of the inside the area 0 will increase. Rather than what we can do, that we can summarize the area 2 as 10.1.8.0 and area 1 as a 10.1.10/21/21, correct? So in that case, we are sending only one update, and our routing table will be efficiently utilized. Doing so, we can reduce the load over the router CPU. So this is one of the interesting use case we have with inter-area OSPF summarization. Now what's the command? Command is very easy and straightforward. We can go to the router, and over the router you can go to the area, and then you have to use the keyword called range, and then you can use the address and the subnet mask, and then this will be done. Now there is one important point to mention, that suppose if you have some of the routes in between, that is not part of subnet. So for example, if I don't have 1.5, 1.6, is still I am using this summarization, that is 10.1.0.0/21. So in that case, what we can do, we can use the concept of static route null zero, and we can point out this summary route towards null zero. So that means that anything that is not matching, that will be garbaged, that will be Bitbucket. Correct. Now here you can see that note that after 12.16, and now we are running the modern or advanced version of operating system. Even this command is not required. It was required for the earlier version of iOS. Now the second point related to summarization we have is, suppose if the summarization is coming from the external system, it's not related to inter area routing, but it is coming from outside. Now at this point of time, we should go to the ASBR. Suppose router B is ASBR, who is connected with non-OSPF domain or non-OSPF routing protocol. So in that case, you can do the summarization, but syntax will be little bit different. So in this case, instead of doing area, the command is summary address and then the network and the subnet mask, means whatever network we want to summarize. Correct. So now this concept is very much like we are doing the aggregation, and we have two type of border. We have ABR and we have ASBR, and like that we can easily do the summarization. Now here you can see that we have one use case in case of ASBR summarization, that if you don't want to advertise certain prefixes, so in that case, you can go specifically to that particular network and you can use the keyword called not advertise. If you use not advertise, obviously these networks will not be advertised inside the OSPF. Okay, so this is the concept related to summarization. Now, next important concept we have is the OSPF area type. Now I have one summary chart as well where we can go and summarize the OSPF area type after a few slides. So here you can see that you have area type called backbone, non-backbone, stub area, totally stubby area, and not so stubby area. That is NSSA in short. So let's learn and discuss about the area type. Now starting with the basic area, that is the normal or the standard area, we know inside that area we have LSA type 1, we have LSA type 2. So here you can see that we have all the LSAs inside the standard area, the type 1, type 2, type 3 and 4 generated by ABR. Then we have type 5 as well, that is generated by the ASBR. So it is able to understand all the LSA. That's the standard area. Now the second thing here, that when you are making a stub, at the moment you will make the area as a stub, the stub will not accept type 3 and type 5. But remember, they will automatically inject the default route. Now doing so, we are not, while doing so, you can think like this, while doing so, we are cutting off the SPF calculation. And who is doing the SPF calculation? My CPU, my process. So that means that we are cutting off the intensive cycles, CPU cycles, and hence we are providing good type of optimization in terms of CPU and memory. Correct? Now, what's the command? Again, the CLI command is very easy and straightforward. You can go to the network. So here you can see a router process. First go to the router process, and then you can go to area 1 stub. At the moment you do the stub, that means it will start stopping type 4 and type 5, although it will get router, network and ABR generated LSA. That is type 1, type 2 and type 3. And other thing is that it is generating the default route. Now the third concept we have is the totally stubby area. Now what totally stubby area even will do, that will accept only type 1 and type 2. It will not accept type 3, type 4 and type 5 LSAs, although it will go and generate the default route for type 3, 4 and 5 LSAs. Again, the use case is that we are saving the bandwidth, we are saving the CPU core, process cycles, etc. Now the command here is interesting that here we have used in a stub area, we have used area 1 stub. For totally a stub area, you have to add one more keyword, that is no summary. So the command is area 1 stub no summary. It will stop LSA 3, 4, 5 and it will generate the default route. Okay. Now the fourth one is not so stubby area. Now, why we need not so stubby area? Here you can see that you may have chance that area 0 is connected with external network, or you may have chance that area 1 is connected with external network. Correct. So in that case, we'll see that when you have area 1 connected with external network and you want to filter some sort of LSA, you are going to use the not so stubby area. Means it's a stubby area, but it's not fully stubby area. What it will do, here we'll see that like a standard stub area, NSSA area routers will share type 1 and type 2 LSAs. Okay, they are not blocking type 1 and type 2. NSSA area will also accept type 3 LSA. So they are going to accept type 1, type 2, type 3. But NSSA will not accept type 4 and type 5. Okay. Now we are going to introduce one new LSA, that is LSA type 7, that we haven't discussed so far, but not so stubby area is linked with LSA type 7. And what's the use of LSA type 7? Now we'll see. So if an ASBR exists within the NSSA area, this is ASBR will generate type 7 LSA. Again, NSSA areas are almost identical to a stub area. If area 1 was configured as NSSA, it would not accept any external route originating from router G as ASBR outside area 1. So here you can see that they are not accepting any type 4 and type 5 LSA. Rather than we have type 7 LSA. So here you can see that it will not accept, this is the router G, it will not accept any external network, external non-OSPF domain network. Correct? Great. However, area 1 also has an ASBR within the area router A. Those external route will be flooded into area 1 as type 7. So here you can see that you have area inside area 1, you have router 1 and who is getting the uh, external routes, and that will be flooded inside area 1. Now these external route will not be forwarded to other area as type 7 LSA. Instead they will convert it into type 5, and that's the key, and that I'm going to summarize. Type 5 LSA by area 1 ABR router C. So what is happening here when you are creating not so stubby area, in that case you are getting type 7 LSAs, and router C, what he will do, he will convert type 7 LSA to type 5 LSA, and then it will flood it into the other area, or the other area will calculate as per the type 5 LSA update. The configuration is very simple. What you have to do, you have one keyword, go to the route process and then area 1 NSSA. Okay. All right, and final concept we have is totally not so stub area. So let me stop here, and remaining concept we'll discuss in the next recording. But here you can see the summary, and in this summary, let me try to highlight backbone LSA 1, 2, 3, 4, and 5. They are not getting LSA 7. Non-backbone like area 1, area 2, etc. They are also getting all the LSA stub area, LSA 1, 2, and 3. Totally stub area only LSA 1 and 2. Remember, they are going to generate the default routes. The not so stubby area type 1, type 2, 3 and type 7. This type 7 will be converted to type 5 and then it will be reaching to area 0. That's the overall summary we have with this recording. So let's stop here and next section will continue from here. Let us continue where we have left off. Now next concept we have is not totally not so stubby area, that is TNSSA. So what is the main difference between a stub and totally a stub area? The same difference you'll find between not so stubby area and totally not so stubby area. Totally not so stubby area will allow LSA type 1 and 2, and he is going to filter type 3, 4 and 5. Here you can see the configuration is very straightforward. You can go to OSPF area and then you can give area 1 NSSA. The keyword is no summary. And here we have the summary just for your reference. Now the next topic we have is OSPF and relation with default routes. We know that when we are generating to a stub area and totally a stubby area, at that time the OSPF process, they are generating the default route. But in case of ABR and ASBR inside a standard area, we don't have default route. Now suppose you are sending LSA type 3 from router C and you are expecting that you are getting say LSA type 5 from router 1. So you are getting LSA 5 from router 1 and it will go to router C and then other areas. Likewise, LSA type 3 will go to B and A and actually B and then A and then the external network. At that time, suppose for the external network, you want to create the gateway as router A, so we can go and create the default route. So here you can see that additionally force router A to generate a default route, including itself as the next hop for the external network and injects into this inside area 1. Okay. What is the command? Command is router process, go to router process and default information originate. So this will inject the default route. But in case suppose you want to force it, so for example, if a default route does not exist in its routing table, router A can still be forced to advertise a default route using always command. So in that case, if I want to force the default route, now we completed OSPF v2 and we have checked lab and theory related to OSPF v2. OSPF v3 is very much similar using same type of concept, but there is little bit of changes. First of all, OSPF v3 is using IPv6 address schema, and for sake of simplicity, I'll show in the lab that what type of IPv6 addressing we are using. So here I'm using this type of lab. You can see we have router R1, R2, R3, 4 and 5. Here you can see 1, 2, 3. These are the router number 4 and 5. Now in this topology, although just for sake of simplicity, I'm using only area 0, but we are not restricted to use just the area 0 piece. We can go and create same type of topology and methodology that we have learned earlier, and multiple areas we can create. All right, coming back to the addressing, what type of addressing we are using. So we have something loopback either 0 or loopback 1. If it is a router 1, so I'm using 1 and then double colon 1/128 as a loopback IPv6 address. So suppose if it is a router number 4, you can see the numbering, it is router number 4 here, and this is router number 5. Let me clean this and let me write one more time. So suppose if this is router number 4, so IPv6 address over loopback address, either loopback 0 or 1, you'll find 4 colon means double colon, and that will be used inside IPv6 4 and then /128. That's the IPv6 address I'm using for loopback. And what about the interfaces? So suppose if this is router 1 and this is router number 4, so IPv6 address that I'm using here will find 14 colon colon 1/64 here and then 14 colon colon 2/64 here. Again, if we have router number 2 and router number 3, so I'm using 23 colon 1/64 here and then 23 colon 2/64 on this interface. So like that you'll find the address schema, and that's why I haven't put all this information in this diagram. Once you see the lab, you'll understand. Very easy and straightforward, correct? And the configuration and the complete configuration you will find in this particular document as well. So once we go, what we need to do, we have to first of all enable IPv6 routing. You'll see that how we are enabling this and all. So once your OSPF IPv6 means OSPF version 3 is up and running, then you can go and verify the router ID. Now router ID, although you can see that it having number very much, this is showing IPv4 type of numbering. That's right. But the point here is this, that this IPv4 type of numbering that we have related to uh, IPv6, you may think that why not we have something 1:1, something like that here as a router ID. Router IDs are not that much important in IPv6. You can see the notes here. So OSPF v3 picks read router ID, exact algorithm used by OSPF version 2. It is 32-bit dotted notation that we have in OSPF version 2, but has nothing to do with IPv4 address. You can use any format, 0001, 025510, etc. Okay, should not use 0.0.0.0 because it is reserved. Apart from that, you can use any 32-bit dotted notation. Now, once we'll go and configure all the routers, and then we'll go and verify router LSA, network LSA, link LSA, inter-area LSA. These are the OSPF version 3 command. I will show you these commands in the lab. Now, what's the difference here? So OSPF v3, you can see, is almost similar, and all the LSA types are almost equal to OSPF version 2. We have two new LSA, link LSA and prefix LSA. Now the summary LSA is now called as a inter-area network, and summary is BR is called as an inter-area router. Correct. Rest of the things you'll find is very much similar. Now, what about the configuration? You can see the configuration. We have 5 routers, so you can see IPv6 related configuration. First of all, we need to go and enable IPv6 unicast routing, and then we can go and do the configuration. So for example, in R1 you can see that loopback1 having this IP, and then loopback1, the command is, we can go to the interface. Once we are over the interface, then we can go and run this command, IPv6 OSPF1 area 0, area 2, area 3, etc. But we know that concept that you have one backbone area, and then rest of the areas are connected with that. We have checked all these things in the previous OSPF version 2 section, correct? Then here you can see that how I have given the IPv6 address just for sake of simplicity. So 14:1/64, then somewhere you'll find 12. So that means if you are at the R1 and if you're going to R4, you'll find 14 address here. And then if you're going to R2, you'll find 12::: here. Okay, /64. So like that, we have used this strategy, and rest of the configuration are almost same, that we have what we are using inside our OSPF version 2. Although you can see the IP address is related to IPv4 as well, but it's up to us that if we are purely inside the IPv6 network, then these addresses are not required. These are the 4 configuration related to router 1 up to 5. So next what we want to do here, I will go and show you in the lab section that everything will be up and running. I'll show you that how you can go and check the OSPF neighbor and then few of the LSA's output in the lab. All right, so let's stop here. I will show you the rest of the output in the lab. Hi there, thanks for your enrollment. We are in 1-minute ad break. In this break, I'm going to show you that I have so many courses uploaded over Udemy. And if you're going to enroll my courses, you will get 95% discount. Every month, 3 times. First week, mid of the month, and the last week of the month. I am sharing the coupons. If you go and use those coupons, then my courses related to CCNP, related to CCI, all those courses, you are going to get heavy discount up to 95%. You can see the prices are a little bit higher here, but if you go and apply the coupon, the prices will go rock bottom. So go use those coupons. Suppose if you don't have those coupons, then you can always ping me over YouTube. You can send me email. You can ask for those coupons. I will provide you that coupon. So get the coupon, get the discount. Some of my courses over Udemy, they are bestseller. Some of the courses are quite new, like SD-WAN automation, DNA automation, CCI data center 3.0. Those are the new uploads as well. So please go, continue your learning, take the coupon, enroll my courses, and study well. All the best. Now we are ready to perform the lab related to OSPF version 3, and let's do it. So already I have done the configuration, and let me log into all these devices one by one. Let me show you this. So same topology that we have seen earlier in the slide in the PPT. I have all those 5 routers which is running here. They are virtual routers over viral environment, but if you want, you can use GNS3 or any other emulation that is available. Now what we can do here, we can go here and we have this script option and we can send to all. So let's select all and use show IPv6 interface brief just to see that what IPv6 interfaces we have in configuration. So here you can see that gig 00, you have your global address, you have the link local addresses as well that is derived there over these interfaces. So gig 01, 02, and likewise you can see all the IPv6 addresses in the same way that we have discussed earlier. If it is R5 to R3, so you will see here 35 colon colon 5, like that we have the address. Now next what we want here is that we want to check the OSPF version 3 configuration. So for that actually we need to go and we can go and check these interfaces. So if you go to these interfaces, only one command is there, that is uh, IPv6 OSPF 1 area 0, and apart from that, let me show you that what other configurations we have. So you can see that I have used IPv6 unicast routing. IPv6 was there automatically, and these configurations we have used. Let me highlight these configurations we have used over the interfaces, and now the OSPF is up and running. Now here if you can go and check the OSPF version 3 neighbor, so you can see here that in broadcast network still it is following the DR BDR rule to form who is the DR BDR etc. We know that how it is forming, we have done this in the previous sections. And router 2, because router number 2 has 3 connected neighbors. One is router number 1, one is router number 5, one is router number 3. So likewise you can see here that it is showing you this information, and here you can see the router ID as well. So in this output, you can see the router ID as well, and there are other outputs as well. We can go and check show IPv6 OSPF, and here you can go and check the ID. So here you can see the router ID. We have the router ID. Show IPv6 OSPF also will give you the detailed information, and then if you want, you can go and do the filtering there as well. So I'll go back to router number 2, and here we can go and check different type of LSA's output. So we can go and check show IPv6 OSPF, and once you are there, you can see that what filters here. We can see good long list of options that we have, but we are looking for database. And after database, you can see that we have options related to a router, a link, network. You will see the router as well, correct? So if you want to check the router, and then we can go and check the self-originated link status. So here you can see that we have the router LSAs. Likewise, we can go and check the network LSAs as well in IPv6. So instead of router, you can go and use the network and then self-originate. You have the network LSAs. Likewise, we can go and check the link as well, link LSAs. So here you can go and check the link LSAs, and finally you can go and check the prefixes as well. So if we have the prefixes, let's see the prefix self-originate. Great. So this is the way that we can go and check all the LSAs, most of the LSAs, but we know that there is good amount of LSAs. But this is the way that we can go and do the implementation, and then again after implementation we can verify as well what's the output we are getting here. And the implementation in all the devices, I told you that I am using only area 0 just to sake of simplicity, but to do the deployment related to version 3, OSPF version 3 is the same. So not a big thing, it's very much same like we are doing inside OSPF version 2. Alright, so let's stop here and we'll move to the next section. In this section, we are going to learn about ISIS protocol and ISIS protocol addressing. So let's learn. Now the evolution of ISIS protocol, that is intermediate system protocol, is different than the OSPF protocol. So at the moment we have two link state protocol. One is ISIS, other hand we have OSPF. We know that OSPF, how popular OSPF is and how widely OSPF is being used. But on other hand, if you go and check the ISP backbone protocol, you'll find that most of the ISPs, service provider, they are using ISIS. Why? Because ISIS has certain characteristics that is unique. When ISO or OSI, when they have created this protocol, they thought, so what was their in their brain is that they need one address, one type of addressing protocol or one type of routing protocol that will be widely used and widely tunable, widely adjustable. So what does it mean? It means that ISIS protocol is a protocol where you have so many field that can be tuned, or it can be used as a IPv4 routing protocol. It can be used as a IPv6 routing protocol. So all those parameters has thought long back earlier before creating ISIS protocol. Since the overall architecture, overall the framework of this particular protocol is complex, that's why it hasn't gained the popularity that we have with the OSPF protocol. But on the other hand, if we go and check the characteristic, like how they are building their routing table, how they are incorporating with IPv6 routing or IPv6 addressing, those characteristics are actually unique in ISIS. That is not there in OSPF. So the thing here is this, that once you go and do the deployment with ISIS, although the addressing scheme is difficult, but once anyhow, if you go and do the deployment, you'll find that after deployment, it's much better. Its performance is much better than OSPF because of its characteristic. That again we'll discuss in upcoming slide. So yeah, so we have two link state protocol. We have OSPF, we have ISIS. Let us quickly check that what are the key areas we have inside ISIS. Now, ISI is also using the hierarchical design, such as the areas. They're also forming three different type of tables. They are forming the neighbor table, topology table, routing table. Neighbor table means my peer table. Topology table means entire database in the network, but still they have different type of L1, L2 routers. The way that they are forming the topology table is different than the way that OSPF is forming the topology table, and OSPF devices are assigned inside ABR, ASPR, and those terms we don't have in ISIS. And then finally, with the help of Dijkstra's shortest algorithm, the same algorithm is used in OSPF. They are building their best path. That's the routing table. Correct. So let's see other characteristic that we have. They also have the LSPs. See here the key area. They are only sending the changes in the update packet. So unlikely that they are sending all the information, whatever update, whatever change is there, that change only they are sending in their LSPs. That is again one of the unique key area we have in the ISIS protocol. Apart from that, their AD value is 115. They have metric value. They have metric value such as delay, expense, and error that Cisco is not using. Cisco is using cost as a metric value inside ISIS. Okay, so you can see now from beginning itself, there are so many differences that how they are sending their LSPs, how they are forming their topology table, how their metric value get calculated. And again, in the upcoming section, when we'll go and check the addressing scheme, we'll find that how different they are with the OSPF, because two link state protocol. So whenever we'll compare with OSPF. Great. So what about the addressing? They are using connectionless network services, and you'll find so many different terms here. In the upcoming slide, I will try to make this simple. I will make this simple. Okay, so let's try to understand about their addressing. So they are using connectionless network protocol. There are two terminology. One terminology is ES to IS, means host to router. That's the protocol is using. So what's the communication protocol in between the host to the router? That is end system to intermediate system. And other one is router to router. So router to router is being used as an intermediate system. And that's the thing that actually both we are using here, but we are going to learn more and more about router to router, in between router, how the exchanges are happening. Okay, now let's go and learn more about ISIS addressing schema. So here you can see that connectionless protocol, the network protocol that we have, having three key field: area, ID, and selector. Correct. Now here you can see that big picture, and you'll find it's how big this is. But anyways, I'm going to break this. I'll make this very simple, that what we are going to use, we have to focus on these areas: area ID, and then the system ID, and then the SEL. These three area we are going to focus, because inside Cisco routers, we are using these three area. Again, in upcoming section, you'll find that you have NCell, and if we are using NCell inside Cisco, that will become NET, and they are part of CNLP, connection less network protocol. So here you can see that connectionless network protocol. And then here, if you make this field 00, you'll find that this is being used inside Cisco routers. Okay, so let me quickly walk you through this, but you have to understand only this portion. Okay, area ID, system ID, and SEL, and that's done with a Cisco router. But apart from that, let's try to understand the other terminologies just for our understanding purpose. So two key fields are there, IDP and DSP. Initial domain part and domain specific part. Initial domain part, that is there to do the route in between autonomous systems. So different autonomous system, they will do use IDP to do the routing. Within the same autonomous system, you are going to use a DSP. Okay, so easy. First, in between two autonomous system, if you have routing. Second field being used if you are doing the routing within the autonomous system, that's easy. Okay, IDP, D stand for domain. So initial domain part and domain specific part. Now let's check all these fields like what is AFI, IDI, HODSP, etc. But again, this and these things are important. Let's see. So AFI, authority and format identifier. What it is 8-bit long, and this is going to specify the organization authorized, means your organization is authorized for this. Now, in your organization, if you have sub-organization, then IDI will come into the picture. So you have AFI, this main organization authority address, and then IDI, that is going to define the serve organization. Now, important point here is this, that if you're addressing, and we are going to learn about this in later section. So if your address will start with 49, that means it's a private address. Like in IPv4 addresses, we have private address range, public address range, etc. Correct? Like 10, 172, etc. So if you are starting with 49, that means private, and if you are starting with 47, that means the public address. That is explained here in the bottom. Okay, key area I have highlighted in blue. So the AFI plus the IDI essentially identify the autonomous system of the address. Okay, so your autonomous system is what? We'll see that area field. Later on, when I will explain about the addressing part, I will tell you, see, this addressing part, for example, 47, I'll use 470001. That will be your area ID, but that is your autonomous system as well. And this is not same as BGP autonomous system. Okay. Okay, great. Let's understand the rest of the portion. So you have HODSP, that high order DSP, that is identify the area within the autonomous system. And you can see that HODSP area within the autonomous system. Again, I'll go and explain in the upcoming section when we have the examples. Then we have system ID, that is 6 octet. You know, 6 octet is your MAC address. When you are creating your MAC addresses, um, in a lab environment, if you have if you are putting hard coding your MAC addresses, so what we are doing, we are giving some number like 1111, then 1111, then 1111, like that. So in this lab also that we are going to do in upcoming section, what I will do, when I will create the address, I'll put say 47001. That will be my area ID. Correct. The first portion is area ID, and then I'll go and put the 6 octet, that's very much similar like MAC address, as a system ID, and then in the last I will put 00. That will be the N cell or NET. Correct. Great. So things are getting simplified here. If I have to form one address, I will go and form say 4700001, and then 1111.1111.1111.00. If 00 is there in the last, that will be your N cell. That means that this is Cisco router. Now this is very much similar like MAC address. This is 6 octet. And then you have the autonomous system or area ID. So this is your area ID. And because we are using 47, that means we are giving public address. If I go and use 49 in this place, you'll find that it is being used as a private address. So I will go and use 49 because we don't want to send our traffic to the public. Okay, great. So we are talking about N-cell and identifies the destination upper layer protocol, always 8-bit. And again, I told you that N-cell and N-cell, NET, NSAP, everything is very much similar. Okay, So please do not confuse. I'm going to summarize that what exactly we want to learn here. Okay, final thing. So the CLNP addresses, so there are two type. NET, if you go and put 00 in the last octet, that will be your Cisco router, and NSAP address, that's a full CLNP addresses. If uh, if you put 00 in the last in the NSAP address, so your NET will equal to NSAP. That only thing you need to remember here. Let me show you the address format. So I'm going to show you an example, and you'll understand from that example that where everything is fitting. You can start reading from right to left. You'll find that NCell, if it is 00, that means this is the Cisco router. Then you have your MAC address type of field, that is a 6 byte. And then you have your autonomous system. So what you can do, you can focus only on 47, rest you can leave it, because anyways you want to complete 20 bytes as a CLNS address, but it's not required. So you can go and simply put 0001, okay, and then 1111, 2222, 3333, and 00. That will be one of your address. One thing here that to understand, that when we are putting the addresses related to ISIS, they are over the device. They are applied over the entire device. They are device specific address. They are not interface specific address. Okay, so that's one of the key here. Again, you can see the example. So you have your area ID, you have your system ID, and you have your NCell. 00 means that it is being used by the Cisco device. All right, so you find it very interesting because the addressing scheme is actually very interesting here. And this is the addressing scheme that we have here. Let's just stop here. Let us continue our discussion and learn more about ISIS packet types and how they are forming their routing table. What different type of ISIS router we have. So each and everything we are going to discuss. Now let's just start with ISIS packet. We have four different type of packet types inside ISIS. Hello, LSP, CSNP, and PSNP. And we are going to understand more and more about what are the importance of all such packet types. Now, suppose if we came from OSPF domain, we know that how OSPF is working. We know that if you have routers in different areas and these routers having different role, maybe they are ABR or ASBR, different areas they may be situated. And then they are sending different type of LSAs, link state advertisement, to form, first of all, they are building the neighbor table, then the topology table, and the routing table. Now the formation of neighbor table, topology table, so I'll write here, neighbor table, topology table, and routing table is almost there in ISIS as well. They are going to form neighbor table with help of Hello Packet Exchange, and again I will cover in next slide. And then they will form the topology table, but the way they are forming the topology table is entirely different. And then finally the Dijkstra algorithm will run and they will form the routing table. That's the best path. Correct. So first of all, let's dig deeper inside all these packet types. And before going there, you can see two more terms here. ES stand for end system. That means end host. And IS is intermediate system. Two intermediate system is router to router. So if you have ES to IS communication, or what type of exchange, packet exchange are there, that we can see. So if we are talking about the Hello packets, in Hello packet, we have three different type of Hello packet. One Hello packet that is exchanging from IS Hello, that means router to router. So in between the routers, then ES Hello means end system to the router, and then IS Hello, that means a router to end system. Correct. So IH is okay. It's something that we can easily understand. It's easy. Router to router Hello packet, when they are building their, when they try to build their neighbor relationship, at that time it will get used. Now ESH, that is from ES discover to router. So end system will discover the router. ISH means router they are announcing to check the presence of the end system. correct? So say if I have one system here, a router here and router here, so you can understand that IIH will be here and ESH in this direction, and then in this direction you have ISH. These hello packets are exchanging, correct? Great. Rest 3, let's understand about LSP, link state packet, and the use of link state packet. Let me clean this here. So LSPs are there. It is used to share the topology information. So once you built the neighbor relationship with the help of hello packets, what you will do, you will go and build the topology table. So how you will go and build the topology table? To build the topology table, you have to send the LSPs link state packet. Now, once they send the link state packet, again there are different type of labels we have in the ISIS. I'm going to explain about the labels as well. So they will send the LSPs and then they will form the topology table. Once you have the topology table, then you can go and run the SPF algorithm on top of that, and you will find the routing table. Correct? So I will come back to this LSPs, but apart from that, we have two more packet type. One is complete sequence number PDU. That means to sync the entire database. So to sync the full link state database after every 15 minute, CSNP will come into the picture. Okay, and then finally you have the PSNP, partial sequence number PDU. What it is going to do is used by ISIS router to both request and acknowledgement. Remember in OSPF we know about that you are sending the LSA, you are getting the LSAC, etc. So those exchanges are happening. So we have the partial sequence number PDU, and they are not the packet PDU, packet datagram unit. So when we are talking about OSI evolved or ISO marked protocol, we are talking about PDUs. And when we are talking about IPv4 protocol stack, we are talking about packets. Great. So let me quickly summarize here about these packets, how they are. So if we have two routers in between, and suppose I'll take one end system as well. So in between, first of all, they will send the hello packets. Different hello packets are there to form, first of all, what? To form the neighbor table. Now, once they form the neighbor table, if they know L1, L2, L1, L2, etc., we are going to discuss about that. Then they will send the LSPs. So these routers will send the LSPs, link state packet, to form the topology table. So you have the big topology table with you, and after that you will run the SPF algorithm to form. So then you run the SPF to form the routing table. Here you are forming the topology table. Apart from that, we have the partial sequence PDU, we have the complete sequence PDU to sync the database completely. We are using the complete sequence PDU, that's the CSNP, and partial sequence, they are just for request and acknowledgement. Great. So I am talking much more about level 1 and level 2 routing. If you go and check the hierarchy of ISIS protocol or the topology of ISIS protocol, you find that you have something called backbone. Like in OSPF, you have backbone. Inside backbone, you have L2 routers. So router labeled as a L2, you can think like this. And then you may have a router having L1, a router may having L1, L2, and then this L1, L2 is connecting with L2 routers that is there in the backbone. And again, let me draw here. And then you may have L1, I should write L1, L2, and this is connected with L1, L1. So clearly it is telling here that L1 routers are there whose database, whose routing information are there local to the area. Suppose they are belonging to one area. So that means that they are local to the area. So L1 routers marked local to the area, and L2 routers are the backbone. They having the complete database, but still they are not someone who is doing the transaction in between. To do the transaction are very much similar like how we have the area border routers. ABRs. You have something called L1, L2 routers marked as L1, L2. What type of router this is? This is L1, L2 router. So who is going to do the communication? So they will take the information from L1, sync with them, send to the L2. They will take the information from L2, sync with him, and send to L1, like that. Okay, so remember we have three level: L1, L1 plus L2, and then only L2. This is there within the area. This can do inter-area type of communication, and this is again there as a backbone. So he has the complete database. Great. So as we already told that, discussed that you have the router, they will send the hello packets. Once they send the hello packets, they will go and form the neighbor relationship. We have two type of area here. One is point to point, other one is broadcast. Inside broadcast also you have two. So we have two for broadcast, L1 and L2 level of broadcast. At the moment, you can think that, oh, you have point-to-point link, means directly connected link, and you have shared media like broadcast network. I have highlighted important point here in the blue, so let me read out. And it's this point will tell you that what's the difference between OSPF and ISIS. So what is this? This is telling that adjacencies are formed across CLNP. We know that's the protocol that ISIS is using, connectionless network protocol connection, not IP connection. So what does it mean? It means that ISIS protocol, they do not require IP connectivity, okay? Because we are not putting IP addresses over the link, you know. In case of ISIS, we have the system designated address. We'll come to know about that. We are not going to the interfaces and putting IP over the interfaces. So that IP information is not required. So what they are doing, they are using this connectionless protocol mechanism to form the neighbor relationship. Correct. And they are forming the L1 adjacency. I already told you that is the intra area within the area, and L2 adjacency that is in between the area. That's the inter area. So inter area and intra area, that's the key we have. Unlike in OSPF, you need IP, correct? IP connectivity. Great. And apart from that, let's quickly discuss about the nature of the broadcast network. So we know that in OSPF, we have to go and do the DR and BDR selection, correct? So who having the highest priority become the DR, and then the BDR, and then the DR other. Those terminologies are there. But in ISIS, and that's the difference, ISIS, you have the designated intermediate system. We can think as a DIR at the moment, like we have in OSPF, but we don't have any backup. So what will happen if DR will go fail, again the protocol will rerun, and then again they will go and form the DR, who having the highest priority, that will become the DR. Correct. So in terms of a broadcast network, they are sending the hello packets. They are using the router level. Again, router level means L1 or L1, L2 or L3, etc. Correct. Same area, you have L1. Different area, you can use L1, L2 or L2. Correct. They are using in Cisco, they can use the clear text authentication. MTU parameters will get matched. So while they are forming the neighbor relationship, obviously with the hello exchange, they will form the neighbor relationship. But while they are going in deep, forming the topology table, so what is the parameter they should match? That is listed here. You can see hello timer, router labels, area, authentication, and MTU. They should match. Now, according to the highest priority, they have the DR selection or DIS selection, that is the designated intermediate system. Default priority is 64. Now, in upcoming lab, you will see that suppose if the priority, they have the tie, then they will go and check who is the highest MAC. And if you go back and check our one of the slide here, you can see that you have this particular system ID that we are going to refer as a MAC. So you have three fields: area ID, system ID, and this is the NSAP, or you can think as a net address. For Cisco, it is 00. Okay, so as per the highest system ID or MAC address is a 6 byte in length. If your priority having the tie, then as per that MAC address, they will become the DIS, designated intermediate system. And the DIS send hello packet every 3.3 seconds. Remember, in case of Cisco, Cisco routers OSPF, in case of OSPF, they are sending the hello packets after every 10 seconds. So here you can see that timers have been tuned. Okay, so we have last few slides just for 2-3 more minutes. Whatever we have studied earlier, I have shown you here in the slide. Same thing you can see here, the labels, the hierarchy inside ISIS, that you have L1, L2 router in the area. You have L2 that will work as a backbone. And then again, you have L1, L2, because only L1, L2 can do the communication with L2, core L2. And only L1, L2 can do the communication with L1 as well. So you have something called L1, L2, who will do the communication with L2, who will do the communication with L1. That's the key we have. Okay, so L1 router, they are within the local boundary, they are within the area. Then you have L1, L2 router, here in the third L1, L2 router, they are working as a border router, and then you have the backbone that having the L2 database, that's the L2 router. Okay, same analogy, just for your reference, I have given here, and we have discussed about each and everything uh, related to the hierarchy, related to packets type. So you can go and pause the recording if you want to check the specific section, because this is little bit lengthier recording. We have discussed about the packet types. Inside hello also you have 3 different type of packet types, correct? Then we have go and check about how they are building the neighbor table, topology table, and routing table. Then we have discussed about a different type of labels that we have inside the ISIS mechanism, like L1, L1, L2, and L2. We have discussed that how they are doing the DR, designated router, more precisely designated intermediate system selection, what's the timers, and then you have the hierarchy and how they are syncing the databases and all. Okay, so we are good here, and we can go and stop here at this point of time. What I will do that when I'll start next section, I will start from the ISIS hierarchy, little bit of revision. We'll go and check this very important point that I've highlighted here, and then we'll build our lab. We'll check our lab. Few of the CLI commands we need to check. I will continue there. Hi there. Thanks for your enrollment. We are in 1 minute ad break. In this break, I'm going to show you that I have so many courses uploaded over Udemy. And if you're going to enroll my courses, you will get 95% discount every month, 3 times. First week, mid of the month, and the last week of the month. I am sharing the coupons. If you go and use those coupons, then my courses related to CCNP, related to CCI, all those courses, you are going to get heavy discount up to 95%. You can see the prices are a little bit higher here, but if you go and apply the coupon, the prices will go rock bottom. So go use those coupons. Suppose if you don't have those coupons, then you can always ping me over YouTube. You can send me email. You can ask for those coupons. I will provide you that coupon. So get the coupon, get the discount. Some of my courses over Udemy, they are bestseller. Some of the courses are quite new, like SD-WAN automation, DNA automation, CCI data center 3.0. Those are the new uploads as well. So please go, continue your learning, take the coupon, enroll my courses, and study well. All the best. Let us start where we left off in the previous section. We know that we have 3 different labels marked in a router, and those labels are as per how they are building their LSPs. So suppose if we are within the area, we have either label 1 router, or we have label 1 label 2 router. Now what is happening if the packet is destined to the local area, means in the same area? So at that time there is no problem, L1 router can send that packet to same L1 router in the same area. But suppose if the packet is destined to the remote area L1 router, so in that case what is happening, that the routers, when they try to send their packet to the remote L1 routers, at that time, first of all, the packet will go to L1, L2, obviously, and then it will go here and here, and like that, they will follow the physical path. So the L1, L2 router that we have, what they are doing, they are marking them as attached bit. So one bit will be shared. That means that this packet is destined that it can go travel all the physical routers in between. Correct. So one very important thing, that if it is local, so there is no marking, but if it is destined for the remote L1, then they have to put the marking bit or the bit. Now that's the one very important thing. The second very important thing is that the routes originated. So think like this, and these attribute we have in BGP as well. So we are giving the highest preference to the locally originated routes, correct? Likewise, if you have two route, one is coming from L1 and one route is that is learned and coming from L2 database, at that time, obviously, you will go and prefer the L1, that's the locally originated route. Correct. So in that database, in that network, you have originated the route as a L1, correct? Or you are learning the route from L2 to L2 to L1, etc. Obviously, you will give more preference. So who has generated the route? Correct. So this is also very important point here in ISIS networking and routing topology. And finally, the ISIS router will refresh the link state topology after every 15 minutes, unlike in OSPF that is using 30 minutes to sync the database, to update the database. Okay, so these are the important points from the previous section. In this section, we want to discuss about the ISIS configuration. Now, ISIS configuration is fairly straightforward. What we need to do, first of all, you have to go and enable the ISIS protocol. Like all other protocols, we are enabling router ISIS, router BGP, router EIGRP, etc. Like that, we can go and enable router ISIS, and then you have to go and give the NET address, net address. Remember, if we are giving 49, that means it's the private address. Then you have the field, that's the area ID, and actually it's like this, system ID and area. So here you can see this is your area ID that we have discussed earlier, and then you have your MAC address type of field, that's a system ID, SID, and then you have the in SAP address we have discussed. If it is 00, that will be the Cisco router, correct? So like that, we can go and assign the NET address, net address. Then finally, what we need to do, what we can do here, so suppose if we have a router 1 here and it is marked as a L1, and then it is connecting with router L1, L2, correct? And this is router number 2. So first of all, you can go and turn on the router ISIS over that. And then if you want, you can go and give that IS type is level 1, or it's level 1, 2, or it's level 2. Correct. So this is a step number 1, this is a step number 2, and the final step that you have to go to the interface level. You have to go to the interface level, and then you have to give the command IP router ISIS. Correct. So this is actually it. 3 steps. But apart from that, if you want to give that what circuit type, so suppose this L1 is connecting with L1, L2. So that also we can go and assign. So we can go and give ISIS circuit type is L1 or L1, L2 or L2, level 2. correct? Now, if you are in the broadcast network, then you can go and assign the manual priority as well. By default, the priority is 64. Suppose if you have three different routers and one of the router you want to make as a DIS, designated IS. So in that case, you can go and give the higher priority. Suppose if I go and give a router one as a priority of 100, that means it will become the DIS. Okay. All right. Apart from that, we can go and do the configuration related to passive interface. We can go and do the configuration related to authentication. Now, the passive interface, at the moment you'll go and enable the passive interface to any of the interfaces. That means they will not take part in ISIS routing. They will not form the ISIS neighbor. Either they are sending any type of packets or receiving any type of packets or PDUs, but they will not go and form the neighbor relationship. What we can do, we can go to the globally, we can enable the passive interface to all the interfaces, and then we can do the no passive interface to the selected interface. Same command that we are doing in other routing protocols. You make everyone uh, as a passive, and then selectively you can go and make it as a no passive interface. Great. And then metric, we know that metric Cisco is supporting only cost, that is by default 10. If you want to change the metric, you can go and change the metric. Cisco does not support delay, expense, and error type of metrics. Again, Cisco routers, they are supporting the plain text authentication. So if you want to give the authentication, we can go to the interface and we can give ISIS password, and we can give the authentication for different label of routers. So suppose if we have L1 routers, you can go and provide the authentication for L1. If we have L2 routers, you can go and provide the authentication to L2. Now the final piece of configuration in our ISIS section is summarization. Okay. Summarization is again very easy, straightforward. You can see that if you want to do the summarization for all these routes listed here, simply we can go to the router process, router ISIS, and give the summary address, and then we can summarize. So we want to summarize as a /14 or /12, etc. It's up to us that first of all, take how much summary you want to do. You want to do summary with /8 or /16 or /24. As per the network, we can go and do the summarization. ISIS supports both internal and external summarizations. Great. So only one thing here on top, that you can see that this particular command you need to give if you want to give the authentication over the entire area. Very much similar like OSPF. So authentication piece is like we are doing in OSPF. The summarization command, although in OSPF we have different summary command, but here for internal, for external, you have same summary commands. So very easy. Go to the router process and give the summary command. Correct. Then the passive interface is also very much similar in other routing protocols as well. So what is different here? Different here is that how we are going and enabling the router ISIS configuration. A four-step, basically you can go and use enable router ISIS, give the NET address. Then over the router, you can go and give that what is the router type. It's L1, L2, L1, L2. Means both. By default, it will be L1/L2, means by default it will be having both the roles. Then we can go to the specific interface where we can go and give the circuit type. There you can go and give the priority as well. There you can go and give the metric as well. There you can go and give the password as well. Correct. All right, so let's stop here, and in next section we have to go and perform the lab task related to whatever we have studied so far. Hi there, thanks for your enrollment. We are in 1 minute ad break. In this break, I'm going to show you that I have so many courses uploaded over Udemy. And if you're going to enroll my courses, you will get 95% discount every month, 3 times. First week, mid of the month, and the last week of the month. I am sharing the coupons. If you go and use those coupons, then my courses related to CCNP, related to CCI, all those courses, you are going to get heavy discount up to 95%. You can see the prices are a little bit higher here, but if you go and apply the coupon, the prices will go rock bottom. So go use those coupons. Suppose if you don't have those coupons, then you can always ping me over YouTube. You can send me email. You can ask for those coupons. I will provide you that coupon. So get the coupon, get the discount. Some of my courses over Udemy, they are bestseller. Some of the courses are quite new, like SD-WAN automation, DNA automation, CCI data center 3.0. Those are the new uploads as well. So please go, continue your learning, take the coupon, enroll my courses, and study well. All the best. This section, we are going to perform the lab task. So what I have done here, you can see in the topology we have. So in this topology, we have, first of all, this area as per our diagram. This area will go and make a 0, 0, 0, 2. And this backbone area I will make a 0, 0, 0, 1, and the last area will make a 0, 0, 0, 3. As per the diagram, I will show the diagram as well. That is there in our slide. And the routers we have, so router, these having router label L1, and in between you can see L1, L2. Again, this is the backbone. So backbone will be L2. Then this is working as a L1, L2, and then you have L1, L1. What I have done for IP addresses here, IPv4 addresses, that if it is router 1, so you can see I use V1 and V3. So here I'm using networks such as 10.1. Router name, so R1 for 1, R3 for 3, and .0. That means here I have .1 and here I have .3. Likewise, I am using 23.0 here in this, and in between this. So let me go and clear all this diagram. Yep. So here you have the network starting with 10.1. Everywhere it will start with 10.1. And then X represent the router 1 and router 2 like that. So here you have X as 13.0. Here you have X as 23.0. Here you have 34. The X represent 13, and then 23 and 34. Here it will be 45.0 network. Here it will be 56. Here it will be 67. Here it will be 68. And then I have created some loopback here over router 1, loopback 1111 up to 1113, because we want to do the route summarization as well. Okay, so this is our overall topology diagram that we want to use, and we want to perform the lab task with respect to this topology. Okay, you can see the interfaces name as well, because once we go and form the IS-IS relationship, we'll go and check the interface level configuration as well. Great. So start with area 0002, and what we need to do as per our theory, we have to go and give the NET address over the routers. So if I am here on the router 1, let me show you the IP configuration first. Here you can see the IP address configuration. I can go to the router and we can enable the process called router ISIS. That means router ISIS get enabled. Now then next we can go and give the NET address. So 49 stand for the private addresses that we are giving, And then I can give say 0002, that is belonging to area number 2 as per our diagram, correct? And then I can go and give the MAC address type of 6 byte field, correct? That's a system ID. So since it's a router 1, I'll do one thing. I'll go and use 11111, 11111, 1111 and 00. And that's it. That's the NET address. Correct. So we enable the router process, and then we have given the NET address. Now, if this router is L1, so we can go and give IS type, and here you can see label 1. So that is very much it, the configuration over this particular router. Let me go and complete this configuration to this particular area, that is area 0002 for R1, R2, and R3, and then we'll go and see that how the neighbor relationship get formed. Okay, so I'll do one thing, check ISIS, the configuration that we have, and yep, so because up to here it will be common in router 2 as well. So I can go here because they belong to same area, and then I'll give 2, 2, 2 and 00, correct? And then the IS type is R2 is also label number 1 because R2 having dual role L1 and L2, correct? One other configuration we have, we should give that configuration as well, that we have to go over the interface and we have to enable the ISIS. So I can go to interface GIG01 and we should give router ISIS routing. So here you can give and give ISIS. There's so many options that we have. So we should go here and enable ISIS, and once we enable the ISIS, then we'll go and check all these features that we have. Okay. Okay, so let me check. Yep, IP router ISIS is the command, and interface loopback 1. We have loopbacks as well. Interface loopback 2, interface loopback 3. Great. So we have done with R1. Let's go to R2, and inside R2 there is also one interface Kiki 0/1. So should go inside Kiki /01 and IP router ISIS. Okay. Great. Now we have to go and do the configuration for router number 3. So first of all, enable this, then go and give the NET address 49002. And because this is R3, we want to use other system ID here. So I'll go and use 33. Okay. And IS type is here. Now, by default, this will be level 1, level 2. So if you're not giving anything, that means it is L1, L2. Then we should go to interface 01, IP router, router ISIS, gig 0/2, router ISIS, and one other interface as well that is going to L2. Oops. That also we can go and enable router ISIS. Now, once we do all this configuration, we need to give the IS circuit type as well. So what does it mean? If we go and check GIG01 IS, you can see the ISIS. Let's see the ISIS circuit type if I can get. So ISIS circuit type is, this is label 1, and we should refer the topology diagram as well. At this point of time, let me go and show you the topology diagram. So here you can see 01 and 02 should be L1 and 03 should be L2. So this is good with 0/1. I should go to 0/2. This is correct, and 0/3 should be L2. Likewise, we can go and give the circuit type to the other interfaces as well. So we are here in 01. This is the circuit type, and then here we can go and give the circuit type as well. Let's check the neighbor relationship. So we can go and check the CLNS neighbor, and I can see that they have the neighbor with protocol ISIS, the level 1. So R1 is neighboring with R3. Likewise, if we go and check only IS neighbors, and you can see the circuit ID, phase, everything. Yeah, if you want, you can go and check this in detail as well. So here we have the detail. We can see the area ID, we can see the IP address, and we can check the interface name 0/1, and the state is up. Now the same thing, if we go and check to the router number 3, let's go and check there as well. So here you can see that it has R1 as a L1 database, R2 as a L1 database, because it has 2 neighbors, correct? And you can see the IP addresses over the neighbor as well. Let me go and show you that if you want to check the ISIS database, like we are checking the topology table inside OSPF, here also we can go and check the topology type. So here you can see, and if you go and check show IP route ISIS, so you can see that L1 exchange, it is showing that it is getting all the L1 advertised routes. We know that over R1 we have these 3 loopbacks, so it is getting those information with 115 as a administrative distance. Correct. All right, so you can see how easy that we can go and configure this. What I will do, let's continue this lab and let's do the configuration for rest of the devices. So I'll go and configure in the same manner. I'll go and configure, enable the NSAP addresses everywhere. So if you go to router number 4, because this is something that is L2 only, correct? So go and do router ISIS, give the net address. So this is 0001 and then 4, 4, 4, and then 00. This is IS type as a label 2, done from the routing process, correct? Then we should go to interface level, and this is the IS, first of all, IP router ISIS, and then ISIS circuit type is label 2. Likewise, we can go to gig 0/2 because it has 2 interface. So here also we should go and enable first of all the IP router ISIS, and here it is circuit as a label 2. Again, if you can go and verify from here. So router 4, here also L2, here also L2. Likewise, router 5 also L2, L2. So router 4 and router 5 configurations very much similar, only that you have to change the NEP address. Rest everything will be almost similar. So first of all, I can go here and enable this. Let's go. Enable conft router ISIS here. I'll go and give 5555, 5555, 5555, 00, correct? And then the rest of the things I can copy. So I'll copy this and paste here. It's also having interface gig is 0/1 and gig is 0/2. So there we need to go and enable these commands. One and two, done. So R1, R2, R3, R4, R5 configuration done. Then we have R6 working as L1, L2. Here also I can go and give the router ISIS net address 490003 this is, and then here I can go and give 666, 6666, 6666 and 00, correct? Then we can go and give IS type is label 1, 2, because if you do not give, it will be L1, L2 only. So once we have this configuration, then we can go to the interface level, and over the interface level, we can go and assign the circuit type, correct? So let's go here to the interface. You can see gig 1 is going towards the L2 and rest is going to L1. So I can go to 0/1 and here IP router ISIS, then ISIS circuit type is label 2. And likewise, we can go and continue the configuration. And we'll do the configuration to rest of the interfaces, but here these interfaces are label 1, gig 0/3, IP router ISIS, and then this is also label 1. Great, 2 more devices we need to configure, and we are very much done that we can go and do some of the other configuration like route summarization, authentication, and others. So let me go here. Oops. Router ISIS will be the first command, and then we should go and give the net address. So 49, here it is 0003, and then I can give the system ID 00. Then it should be level 1, and then we can go to the interface IP router ISIS, then what will be the circuit type? So ISIS circuit type is label 1, very much done. And then we have the last router. There also you have only one interface enabled. So we can go to the router number 8. Router ISIS, net address. This is 003. We should have the correct area everywhere. So they're part of 003. They are part of 003. That's correct. All right, and give 8888, 8888, 8888, 00. And this is also IS type is label 1. And then we can go to the interface level where we can give IP router ISIS, and the ISIS circuit type is label 1. Now we can go and check all those configuration one by one. So you can go and check CLNS show CLNS neighbor. That's the first command. Then you can go and check CLNS neighbor in detail if you want to check. So here you can go and check CLNS neighbor, IS neighbors detail. Then we can go and check the interface label as well. So interface is Kiki 0/1. And let's see that detail as well. So it is telling that this is routing protocol IS. Circuit type is level 1. The metric is 10. Priority by default 64. Okay. All this information. Then we can go and check the database. So IS database is the database table. Then we can go and check the topology table. So you can go and check the topology table like this. Then you can go and check the routing table. Great, we are getting the default summarization route. Because this L1 route is there working as a stub that we have in our OSPF. So L1 is sending only L1 routes or L1 LSPs to other devices. If it is local, it will go. If it is remote, it will tag as a ATT, correct? Great. So we have done this configuration so far, and what we want that we want to check the other configurations as well. So let's stop here, and then I will go and check the rest of the configurations. Great. So we have a few verification command. What we have done so far that we have completed our lab section, means we have done the basic configuration. We have enabled the routing. We have given the net address. We have given the circuit type. Everything we have done so far. Next, what we want, if you want to change the metric, you can go and change the IS. You can go and check the IS metric. You can do the changing if you want to set the password. So I will go and set the level 1 password, and we can go and set the level 1 password. Even we can go over the area as well. So area password also will go and set. Okay, so let me quickly do this setting of the password first. So I can go back here to the lab that we have, and we can go to the R1, and we can go to interface kick 0/1. And here we can go and give the ISIS password, Cisco. And while doing this password, remember that we have option here. We want to set the level 1 password. At the moment I have given that, you can see that we are getting the authentication issue. And what we can do here, that I can go to the R1 now, R2. And here also gig 0/1, I can, interface gig 0/1, I can go and give the password as a label 1. Okay, so both places I have given the password as a label 1, and we are still getting the IIH. You can see IIH hello packets generating the authentication issue. Here also you can see IIH, they are getting failed. What I'll do here, I'll go to the router ISIS, and if you go to the area password, Cisco, let's leave it as a Cisco only. So I'll go and change the area password here, router ISIS, and the area password is Cisco. Okay, and here also we can go and give the password. So router, let's go to the interface kick E. And what interface we have? So here we have two interface, 01 and 02. That is going to both the routers. ISIS password Cisco, interface kick is 0/2. ISIS password. I should give the label here. Cisco, and the label is level 1, like that. Great. So now if you come back here and let's see first of all the configuration over the Gigi 0/1. So here you can see that it has taken the password. Let me remove this. And then I want to give the password as a label 1. Okay, and here also. Oops. 0/1, no. And then label 1. And here also interface gig 0/1, no. And then label 1. Great. Now let's check the configuration one more time. 0/1. So I can see that we have given the label 1 password like this. And now it has LSP authentication failure. That's okay. And over the area password is Cisco IS type is level 1. So now what we can do here, we can go and check show CLNS neighbor. I can see IP route ISIS. Okay, so I can see that neighbor is forming, but they have issue related to LSP authentication is failing. Okay, and let's see on R2. R2 also LSP authentication is failing. Let's check here. So I can go ahead and check show run interface Gigi 0/1. Let's see what label of password we have given. Label 1. That's 100% correct. And what about 2? So let's check the interface number 2. Here you can see that here also it is correct. I'll do one thing quickly. I'll go to router ISIS and no area password Cisco. Let's remove that area password. And here also I don't want that. Great. And then show better we can go and check ISIS topology table. Because if it will form the topology table, then obviously we can go and check the routing table as well. Let's check IP route ISIS. I can see now we are getting the information here and do show IP route IS. Oops. My system is a little bit slow. I should get the loopbacks. Okay, actually we are getting all the routes from everywhere. So we are getting the L2 routes, we are getting the L1 routes. So this is the way that you can go and do the configuration. Likewise, I can go and do the summary as well. And next, so this is the topology that we are following here. I have given the router name like this and the IP addresses we have discussed earlier. Then what are the verification commands? So here you can see the verification commands that we have. Those verification commands I'm using: CLNS neighbor, is neighbor. You can go to the interface, you can check the database, you can check the topology, correct? So let's go and run the last verification that we want to do the summarization. And I can go here and I can do the summarization, say 1110 and then 255.255.255.248. Now if you go to R3, let's check the routes that we are getting. So we should get one summary route related to 1110 because we are doing this summarization at R1 level. Because anyways, R1 is generating the route. So I'll do one thing. Let's do this thing. Let's go to the R4 and R5 connectivity we have. So R3 and R4 connectivity is there. Let's see here. Show IP route ISIS. So here you can see that we have all this summarization, and I'll go to the boundary router. I'll go here and do the summary address for 1.1.1.0 255.255.255.248. And let's see. You can see that it got summarized /29. Great. So these are the lab tasks related to ISIS. It was there as per blueprint. Let's stop here. We have completed all the tasks.